Hello, everybody. We'll be starting in a few minutes, so I would like to ask everybody to be seated and get ready. First of all, good morning. How is everybody doing? I hope everybody got the chance to grab a cup of coffee and you're ready for a great conference today. My name is Juana, and I'm going to be moderating the main stage for you guys today. I'll start by saying a few words about myself. I am a front-end developer and a UX designer, and I've been working in freelance for 5 years. I am born and raised in Cluj, and I'm really, really proud about it. And most importantly, I am the co-founder of Romanian IT, the global community of Romanians in tech. Okay, now that I've told you a few words about myself, I would like to know more about you guys. So let's start by playing a good old raise your hands game. Who is here for the first time at Dev Talks? Wow, wow, looking good, looking good. How many of you are students here? Okay. How many of you are developers? Okay. How many of you are entrepreneurs? What's happening, guys? What's happening? Who likes beer? I don't believe you guys. You should raise your hand. Okay. Now I would like to play another little game with you guys. And for this, I'd like everybody to stand up. Oh, I know. Don't hate me, don't hate me. First of all, shake it off a little bit. Let's get warmed up. And then turn to your neighbor, left or right, whichever suits you. Shake their hands. Tell them your name, and tell them why Dev Talk rocks. Okay? All good then, thank you. I think you all deserve a round of applause for that. Great job, guys. Great job. Okay. This is to all the people saying that developers are shy. They're not. Now that we're all warmed up, I would like to talk about today a little bit. The reason why we're all here today, what has brought us all here together today, is our passion for technology. Technology has played such an important role in our lives and our society in the past 100 years. It has changed the way our society works, and it has changed the way a day in our lives looks like. The amazing things are yet to come. Technologies like IoT, smart devices, AI are changing the way that we work as a society, are changing our daily habits, and these are all topics that Dev Talks, this is why Dev Talks is so interesting, because these are all topics that Dev Talks will touch today. We have 6 stages. We have the main stage we're on today. We have web and mobile, we have Java, we have project management, we have big data and cloud. We also have 2 workshops, and you are all welcome to attend them. And I'm encouraging you to go through all the rooms today and take a peek at all of them. Don't just come here to the main stage and stay here. Walk around, see what all the rooms are about, and interact with people. For this, I would like to give a big shout out to the Dev Talks team for pulling this off, for bringing together more than 70 speakers from Romania and from all over the world, for the 10 amazing keynotes we're going to have, for all the startup pitches, and for the workshops. So let's give a shout out to the Dev Talks team. I was telling you earlier that I'm the co-founder of Romanian IT. This is the global community of all Romanians in tech. We are 940 people, students, developers, and entrepreneurs all around the world. My job is to go all over the world, meet with influencers, with community leaders, and to bring together all the Romanians working in IT worldwide. Everywhere I go, I get to say that I'm proud to be Romanian and to brag about the amazing things that are happening in Romania in the IT sector. This is all because of you guys, because of your talent, your effort, your dedication, and the amazing work you're doing. So thank you for that, and I'm very proud to be here tonight. Okay, just a quick update. We're gonna get started. As I was saying, on the main stage we have prepared 10 keynotes, 10 startup pitches, and 2 awesome panels. We are going to kick it off with a panel that covers a subject I'm sure you're all interested in. It's about software developers in a robotic future and programming ethics. I welcome on the stage for this Silviu Șerban. Silviu is the founder of Helios Vision and a computer vision and machine intelligence expert. He will be introducing the speakers in the panel, and he will be moderating this panel tonight. Welcome.
Hello. Thank you, Anna. So I'm going to invite my fellow talkies, I guess, Anatol Priscaru, Marcel Cremene, Andrei Crăciun. So please take your turns and speak up a little bit about yourself.
Hello guys, I'm glad to see all of you here today. How are you? How are you feeling? Yay. Good. My name is Anatol Priscaru. I have a background of a developer, so I came from web development. But during web development, I really liked to take a look at the security part, because we often see that A lot of developers code and they have conferences about developers, but they don't put an effort into securing their applications. So this took my attention, and I founded a community. It's called Security Espresso, where we make monthly meetups and talk about security in a way that we're focusing all of our attention to developers.
Hello, I am Marcel Cremene. I work for 8x8. I'm a Java backend developer. Before working for 8x8, I worked 15 years in a university. I am still associate professor with Technical University of Cluj-Napoca, where I teach courses about mobile communication, Android development, neural networks. I will try to use my knowledge about machine learning, and I hope you will have an interesting panel because the subject is really, really interesting, and I'm very impatient to discuss with my colleagues the subject. Thank you.
Hello, I'm Andrei. I make a living out of software development. I'm a software architect for Avalon CETEX, and in my spare times I do all kinds of things, from developing all kinds of tools, robots, systems, beekeeping, you name it. Thanks.
Okay, so we're going to start with this first question. So it's about AI. So what are the short-term and long-term effects of adopting AI?
Okay, so short term. I'm not sure how to define short term, but I think for companies that will not be able to adapt to AI, there's going to be issues. Imagine what happened when internet and technology, information technology was on the market with bookstores. A lot of them that did not adapt to online reading, online selling of books, they got bankrupt. The same thing I think is going to happen to the companies on the short term. On the long term, on the other way, I think society is going to be affected, meaning that let's say when we fully adopt, we're going to be like, I don't know, 8-9 billion people on the planet, and probably 1 or 2 billion will be replaced by robots, by intelligent machines that will be able to carry to do what they do for a living now. And at that point, we're going to have to rethink our contribution to society. Now, what we do, we work, we pay taxes, we pay insurances, health insurances, but in the future, people may not be needed. And of course, we have to rethink this, and this is going to be probably a big issue that will affect everybody.
Okay, first of all, I want to remember that about AE, there was a high expectation before in the past. At some point, there was this idea of creating an artificial brain. And after that period, the results were not so good, but recently we have very, very interesting results, so the AE is back in the game. About the short-term effects, well, I expect to see some of the mechanical tasks, some of the tasks that are easy to automatize, to be replaced by software or hardware robots, because it's normal, we prefer to do more creative tasks as humans and have a replacement for the boring tasks that are repetitive and simple. Maybe some people think that a part of the developer's work will be replaced by artificial intelligence, and I think it can be true, but it will be the part that is very, very mechanical and maybe algorithmized. Because, for instance, we have artificial intelligence tools that create electronic circuits, but this not means that all electronic circuits are designed by artificial intelligence. So I think in the short term, we will see a part of the tasks replaced by artificial intelligence. In the long term, we may expect to see maybe robots like Asimov described, and maybe having in the kitchen a robot that will help us to make the food or things like this. Well, it's always difficult to predict the future, but it's necessary to think about the future and about the problems that will be raised by that future.
I'd like to point the attention to the fact that our day-to-day life is getting improved bit by bit by AI. We see small components in things that maybe we don't expect. Most of us doesn't expect an AI engine in something that, let's say, he will use a driving app like Waze or something like that in the morning to get to his office. So people wouldn't expect, or maybe they will use this app day to day, but they wouldn't know that actually their path is optimized by an AI algorithm. And I think there's a lot of potential in a lot of small things and small apps and small things that we use day to day that will get improved by AI, and it will soon start to be a part of our life without us realizing it. It will be more important than we think, and I believe we should take a good look at what's around us and analyze what can be improved by AI and what is already improved, so we can get on the same page as everyone else and start from there improving even further. Besides this, I'd like, of course, to draw attention to the security part. It's quite a hot topic. It took off recently, or for a couple of years already. There are a lot of security companies, and I think AI is not yet covered by the security, and the industry is not yet having a really good look at what it is and how should we approach it. On the long term, it all depends on how we will interpret this AI thinking and how we will improve it and secure it.
So to continue your idea, how likely will AI be to be affected, controlled by hackers or malware?
I believe that as every software that we have today, there will always be a possibility that someone will take control over something. How many of you guys heard of the WannaCry ransomware virus? Well, you all know that we all believe that it is. We all knew that there are viruses, but this ransomware took it a step further. Basically, you usually know that you shouldn't open dangerous files from the internet and from unknown emails and so on. What this virus did is they took an exploit from NSA, they implemented it, and started to spread. Just by having your computer open to the internet, it would infect you. So think about it. Software is not perfect. There's no perfect software. There will always be vulnerabilities. So we really should think about it. And we should control how much power do we give to the AI and how much control does it have.
So even considering what you just said, will AI reduce the risks for catastrophes? I'm thinking not car crashes or anything, but more like Chernobyl or Fukushima.
Well, that's a bit far from. It all depends on the security model actually, because we know AI can improve a lot, and we tend to give it more control. So even if we'll get back to the car example, AI has a lot of control of that car. If something goes wrong, the security model should not allow it to crash. It should safely stop, as safely as possible. Even if it's completely in an unusable state, maybe half an engine doesn't work, it should have a safety mechanism that should stop the car safely. Meanwhile, we should think about the example if someone would take over the car. We've heard lately about not AI hacking, but car hacking, and hackers were able to take over cars, to hit the brakes while the car was driving, and it happens like in movies. There was I don't remember which one of the Fast and Furious, but they took over the car and stopped it. Remember that scene? What? No? What they did, they threw a device in the car, and after that they took over the car. But that's not necessary, because hackers have been doing it already.
I'm asking also from the perspective of evolution of AI. So I'm referring to the predictive abilities of future AI, how they could actually change how safety works for all of us.
Well, the AI tools may predict some aspects, but there are other aspects that cannot be predicted. For instance, the market or the climatic system. It's very difficult to predict it. The question was about the catastrophes, because it's a complex system and there are a lot of parameters, and we may have things like chaos in such systems, meaning that a small change in a point will dramatically change the entire system. So this is why some things cannot be predicted, even if we have a lot of computational power. But I think that we can predict more things if we have better machine learning tools, obviously. But for instance, the earthquakes, we know they cannot be predicted before. Only detected, I don't know, minutes before, but not days before. So some things can be predicted, but other things are really difficult to predict because of the chaos, for instance.
Statistically speaking, I think AI will reduce the risk of catastrophes. That would be, but the impact we're going to have is going to be bigger. Imagine that now we rely on cars, right? Just, by the way, I'm a person that is afraid to drive cars which have automatic gear drives, because I think the car does things for me. I cannot fully control it. You can call me a control freak, but that's another story. And so imagine that some device, some machine takes decisions for a person. That impact is going to be bigger. Car crashes happen every day. Still, when a Tesla car crashed, we saw it on the news. That's one side because of Tesla being a big company, but on one side is because the fact that people and humanity is still not used with somebody else to take decisions for each individual. So I guess statistically will be less catastrophic events, but the impact will going to be way bigger.
Okay, so let's hop on to something even more important than this. How will the development of AI affect, let's say, software developer jobs in the future?
So, software developer jobs have been affected by our own products since the very beginning. If we imagine what technologies we've used, 30 years ago, now they are fully obsolete. Well, there are still some on the market, but the market is pretty slow. So we are constantly sabotaging ourselves. So we are developing tools that we're gonna do our job for us. But that does not mean we should not adapt. We are creative people. We should adapt to this. And the part that we will never be able to replace is the creativity part. So that will remain for the humanity, and I think that will be forever.
Any other opinions?
Well, I think some jobs will disappear, but other jobs will appear. And I expect that the new AI tools will create new jobs for creating robots. And also for using the AI tools, because I see an AI tool as a tool. It has some autonomy, but it is still a tool. So someone should control that tool. How do we control such tools? Maybe we will have a new science about controlling robots and artificial intelligence tools. So I expect to see new jobs, and this is also an opinion that was expressed by other persons, considering also the past. There were jobs in the past that do not exist today. About the programmer's work, well, I think the programmer work is mainly a decision-making process. This is true for life in general. We are making decisions almost any moment. So maybe a part of these decisions will be taken by an artificial intelligence application, but there will always be decisions to be taken by humans, because I cannot imagine a future where humans do not take decisions.
I'm really skeptical about AI taking over the job of a programmer. I'm really skeptical about it, at least in the near future. Because let's imagine 100 years from now, yeah, that may be possible. But let's imagine how it will look in 10 years, let's say. So we have a programmer that today does code. And we're talking about an intelligent system that will code instead of a programmer. But how will humanity tell that tool, that robot, that program, what do they want? There will be still some technical specifications because I really think we're still far from being near the moment where our tools will understand natural language and will understand the needs and will code an application for us. So I imagine that there might be some automatized robot AI that will build a program, but there will be a new job to translate the natural language into a specification for that AI robot to build a program. And that will be the new job of the programmer. So the programmer, as you know it, will still be there. That's how I see the things.
All right. So let's switch to a question in an ethical area. So who will be responsible for accidents produced by AIs? The engineers or the user?
It's really difficult to say the answer to this one because let's think about the present and let's analyze what happens when a Tesla car crashes. You cannot blame the programmer itself. Maybe you can blame the company, but can you? What do you think?
Legally, I'm sure everybody covers themselves, but I think we should take a look on this issue from a moral point of view. So now, if we have a bug, everyone is covered. So the developer is not guilty because it needs to have a QA. The QA is not guilty because the process is not working. Then the process is working, but the DevOps did something, and everybody can throw the guilt on somebody else. But if you build a software and then there people die, I think we should look on a totally different way. I was once involved in such a product. It was something for the medical industry, used in a surgical environment, And the pressure was way higher than developing any other software that did not affect human lives. So legally, probably is going to be the one who has less expensive lawyers. But morally, I think everybody should involve and should be responsible.
Well, about the responsibility, well, I think each engineer should ask himself ethical questions. But on the other hand, if an engineer develops a component, he doesn't know always how that component will be used, and that component itself may be something that it's only a part of a bigger system. So it is difficult to make responsible an engineer for the result of his work. But I think, for instance, taking the case of autonomous cars, I expect to have some institutions that will approve or disapprove the use of such cars. So I expect to have some rules in order to allow such cars to be used in the real world. Because you cannot make responsible an engineer for, I don't know, what component of that car. This is my opinion.
All right, so we're almost done. What we would like from you guys is a couple of questions regarding our topic. Okay.
I'm gonna grab your mic. Who got a question?
Hello. One of the biggest problems that I see with machine learning systems is that they evolve and they learn from the user. They continuously learn while we are using them in production. And since we are talking about security, one of the issues here would be that, well, a person with some bad intents would use the product in such a way that it would lead to something like what happened to Ty, the Microsoft bot. The Microsoft bot that turned racist. So how would you approach such a situation from a security point of view?
Well, I believe this is actually more a question about ethics, because there wasn't a direct danger to someone. It only was not pleasant. It didn't harm anyone directly. But from the security point of view, AI systems, I thought about it, and I think there are actually three main categories that we should think when we're talking about security in AI. First of all, I thought about an AI system that's influenced by the decision of an application. I'll bring an example. You all know the Pokemon game, so Pokemon Go, and they had a big issue with the bots. So someone reverse engineered the application. They built bots, and while we all were running and actually going through the city to gyms and stops, someone would simply run an application, and it will crawl the entire city and take over everything without him just leaving the bed. And in order to prevent this, Niantic is hiring artificial intelligence and machine learning specialists to detect the behavior of a human versus a bot. And what I think is possible is that someone would take the movements of a player, of a real player, and slightly adjust them in order to influence the machine learning algorithm to think that a bot is actually a human. That's one category. Second would be if an attacker would be able to take over the entire system that has an AI component. And that's not necessarily AI's fault, but rather the software in general. As it happens, day-to-day viruses, attacks, just like that, someone would be able to take over that system. And we should think we should model the security around it in such a way that that AI wouldn't be able to take great actions and have big power over something that's really important. Let's say there's a system with AI that controls a power grid. It should have some limitations, some safety checks, and turn it off in case someone takes over the entire thing. And the third and final category would be if the AI itself would start creating danger on humans, on other systems, without humans trying to attack it or hackers being the starters of the action. And that, I believe, is a more deep question and maybe not really applicable to the current day, but in some futuristic, in a couple of years, future.
Thank you.
Hello, I have a question. What do you think about the impact of AI regarding the legislation of the countries? Do you think that governments can be stopped in the way of our progress? Generally, and yeah, maybe specifically to Romania or the United States, because there we can see some more advanced things. Thank you.
Okay, so the question was about what governments can do about the AI legislation, right?
Yes, and how can we make sure that the government doesn't stop the progress in this area?
Probably by going to vote or something like this, but for sure there will be some moment in time when we'll have to decide. We either embrace technology in the new way with AI, IoT, and all that comes, or we're going to go on the other side and reject it. Probably governments will be more involved on the, as I said before, on the social part as covering the jobs that are taken over by technology. On the other side, there will be concerns about safety, but I do not think we'll go on general on points like this software is forbidden or this approach is forbidden or research on this area is forbidden. The biggest restrictions I see, it will be that there will be agencies, governmental agencies that will make reviews on generated tools, on, for instance, autonomous cars. They'll have to pass some tests made by authorities, but I think that will be the biggest restrictions we'll see, at least in our lifetime.
Okay, thank you.
All right, so thank you for the questions, and we'll be available outside for, let's say, further inquiries, and thank you for attending our panel.
Thank you guys for the great talk. Thank you for sharing all this information with us, and I think I'm gonna see you guys, most of you, later too. We have a 15 minutes setup break because we're going to separate the main stage from the big data and mobile stages. I'd like to make a quick update. Due to personal reasons, two of our speakers, Oana Călugăr and Cluj-Napoca, will not be able to make it today, but rest assured we have it covered. They have been replaced by other speakers just as awesome as they are. Thank you very much. I would like you to remain seated because we're gonna have our next keynote in 15 minutes, and I encourage you to take the time to network and interact with your with other participants. Okay? See you in 15 minutes.
Right. This is where you get like complex data systems inside of a web browser. So that's really good. You can do some complex things without even having to look at a server. I'm a back-end dev, but I do front-end stuff because I can do things with IndexedDB and not care about writing a server and fake it really well. So there's a slight problem with this. Most people think about it because it's got the word DB, people think it is immediately SQL in the browser. It's really not SQL in the browser. It's just a transactional data system in the browser. It doesn't have SQL, and it doesn't work properly like SQL, so don't even expect it's SQL. It's also this wonderful thing of browser compatibility, so depending on how old the browser you're trying to interact with is, or which version specifically, you get better performance out of WebSQL, which is an older, crappier technology than you do out of IndexedDB. However, you should be using IndexedDB because it's the more performant and the one that's still in spec and still be maintained. Actually, why don't you give up this? Do you know if WebSQL is still being maintained? No. Yeah, except it's still a thing.
It kind of dies though.
Yeah, it's still a thing. So, you know, as with all things, when you have vendors, it's not all rosy because you've still got wonderful problems to deal with. You have API differences between WebSQL, IndexedDB, and specific browsers having different versions of IndexedDB, which means you end up having to hand roll something that covers all browsers. You end up having to do some detection work to make sure you're looking at the right browser and doing the right set of abstractions. You then have to write some abstraction code so that it makes more sense when you're trying to play with it in the browser from a library. And then you have to try and sync everything up and hope that all the bits you've plugged together kind of work. And a few months later, if you've been doing this from scratch, you kind of die. It's just what happens, because that hurts. But there is another way. There is local forage and a bunch of other databases, well, database abstractions like DexyDB, and this wonderful thing called PouchDB. Now, for the purpose of this talk, we're completely skipping everything and going to PouchDB. This thing is absolutely and utterly amazing. And I need to talk a little bit more to complete the GIF, yes. So, what's so special about PouchDB? Well, it's in database browser. In database browser? I think I meant in browser database. It's kind of great. You can also use it in Node against LevelDB, so you can have a local abstraction version of it. It happens to be an interface library for CouchDB. So how about we actually see how this thing works? In Node, you npm install PouchDB. So kind of like everything else involving npm install all the things. And then you just instantiate it and reference a database. In the browser, nearly as simple, except once again we have more package managers to play with. So there's old school Bower, reference it, npm, reference it, cdn, reference it, instantiate a database. You can even use it as a client, so if you are looking at a remote CouchDB, you just go new instance, point at remote CouchDB, and then it works like any other database browser, database driver you've used. And the great thing about Pouch is, unlike how you normally have to interact with WebSQL and IndexedDB, it is very simple JSON docs. Yay for simple data storage objects. For some reason, I'm just looking at that and going, that doesn't look right. Nope, that's just my highlighting has not rendered it correctly. Great. So yeah, so it's a simple JSON doc. So when we create an object, and we actually put some information in there, we just do a post. We do a read, we just grab it by its ID. Simple. We do an update, we grab it by its ID and update it, because unfortunately this follows a revision-based pattern, so when you update it, you actually have to update it based on the previous versions you were looking at. Otherwise you get conflicts and then a whole other bag of pain comes into play. So let's ignore that for now, because pain is not good. There's also the put update, so you can do, put create, sorry. So you can do the same as a post, but this way you get to define more things like its ID, etc. So in this case, we get to set what the ID of the object is rather than a random alphanumeric string. That's kind of good. And then there is my favorite. I may have a slight God complex, so it is definitely destroy, not delete. So it's get and then remove the object based on its ID as well. So that's the basics covered. Everybody still with me? Hands up if you're still with me. All right, hands up if you're bored out of your head. Ooh, nobody here is honest. Right, so that's all the simple CRUD stuff that we're all used to playing with data stores. Now let's look at why this stuff is backtrack crazy. So you can do bulk actions. Yes, somebody decided that it would be great to copy the CouchDB spec and be able to do bulk create and bulk read actions. Who in their right mind is going to be creating hundreds of objects in the browser immediately? Don't say anything. Yeah, not good, especially with, locking up in the DOM and doing horrible things in the front end. But you can do it. There's also this thing called the changes feed. So just like any other database, you have deltas so you can see when those change. This thing throws up events for when you change things in the data store. Really useful. So monkey about with it, and then throw stuff back up to the DOM. Pretty useful. Also attachments. I don't know whose idea this was, but you could attach items to the document. I don't know if that's insane or wonderful. But you can actually just attach a Word doc, a WAV, a video. I have seen people attach MP3 files through this. And my brain just wonders what kind of crazy and what they were smoking when they did that. But it's possible. And then for querying to do complex things, you've then got MapReduce. Who here has used MapReduce? A few people. Do you all pretty much hate it? Does the theory just make you go, no? Okay, nobody's being honest with me again. I'm not appreciating this, honestly. All right, so you can apply a design doc which allows you to do a MapReduce function. So in this case, we're just omitting the type of the document. So meetup, conference, etc., the style of the objects you can see, and applying a date function to it. We also happen to then put that into the database, and we then can query on it. So you can do more than just ID lookups like a key value store. You can do complex things, kinda, in the browser. Really, really, really love doing this, but it's one of those things where it scares me if somebody decides to do something genuinely insane and then blames me when it breaks. So, do querying MapReduce. You then got replication. So, you can tell Pouch to replicate itself between instances. Weirdly enough, you can create multiple instances of Pouch in the same browser and get it to replicate between itself. I challenge you to do this and to just wait for your browser to burn in hell, especially if you're running Chrome. It's funny. It just goes, it's a cold winter's night, set it up and you'll be warm for the rest of the evening. All right, so replication then leads on to this next clever bit of tech, which is sync. So via long polling, sync can update itself from a remote database. And how it does all this is this wonderful little magic bit called CouchDB. Anybody have a clue what I'm talking about? No hands, no nods, no acknowledgements. Wow. Okay. CouchDB is a thing, people. It's genuinely a thing. It's a wonderful JSON document store which doesn't have any database drivers. It's HTTP, so you can do all your CRUD methodologies, advanced lookups, really just normal operational database stuff. And it's over HTTP. It's really that lazy. It's great. It's like having a REST API for your database. Silence. Wow. I thought my entertainment value was pretty high. Right, so this is where we do actually get entertaining. We're going to enter the danger zone, and I'm going to do some stupid live coding. Just wait for the gods of demos to cry and point at me and laugh. So here we go. I should probably turn off the display. Yeah. Right, so. We have a little app here. And I'm going to be really, really annoying and make it interactive. So everybody here got a phone? Who here wants to troll me live? Okay, get your phone out and go to that domain. Let's just check that yep, it's still live. It's a free tunneling tool, people. I'm not complaining about what it gives you. All right, I'm just watching the penguins feed. And when it stops, we'll carry on. You can tell when people are really, really worried about certain characters, and like 2 characters later, their head's back up. You know, it's a phone. You could probably point the phone at it and just read over the corner. It's not at school. You don't need to hide it anymore. All right, we're good. You know, there's a couple more penguins. I know I'm cruel, but this is going to be funny, so it'll be worth it. I should also warn you, well, not warn you, but tell you, Markdown is accepted and it works with emojis. So if I see unicorn rainbow poo, I'm going to be happy. All right, think we're good now. Okay, right, so we have a little talk, and it's going to do nothing. I'm going to make message, and it's going to do utterly nothing. You know why? Because I haven't actually written the app. Which means also, you can do nothing because I haven't written the app. So the simple thing here is we have to instantiate a database to actually do this with. So in our case, as I've been lauding about Pouch, we will go with create a Pouch instance. Yeah, it's kind of useful, kind of what we want. Great. However, now I'm going to be really lazy, and I'm going to copy and paste it. So, yep, I wrote all my cheat sheets here. Because never trust the demigods, all live coding. So now we actually have something. We've got a database, and we're going to, on submit the action, we're going to grab the information and then post it to the database. Simple. So if I reload, yeah, I was warned yesterday. Seriously, did everybody in the room decide to do this? Usually I get like 6 people, and it's like, yes, that's fine. What happens if I cheat? No, that doesn't work either. Right, I'm just going to have to wait for one of you to time out and go away. There we go, or I can cheat and, nope, that's the wrong local demo. I'm professional, honest. I now have a slight problem if I can't remember what the host number was. Port. It was port 8000. What are you talking about? Oh, great. You know that wonderful thing when you build an offline thing and it's using the offline data first? Right, let's solve that. Here we go. So we now have a wonderful little test demo. Moving on. And it's going to be saving information. So those of you who've connected to it, you should see information. Oh wait, no you won't, because there's nothing happening. There's no actual changes. There'll be information in the database. So we want to, every time we've posted something to the database, we want to respond and act in the DOM. So this is where I once again return to my cheat sheet and grab this. This is where it'll just grab all the information from the database and dump it into the DOM for me. Pretty useful. So I reload. Hello world! Hi! Oh, that was really high-pitched. Sorry. Right, so that function is quite simply just going to the database, requesting everything, telling it to give everything but everything in the metadata. Normally it'll just return the ID, the rev key, and any conflict information. If you tell it to include docs, it'll return everything. Really useful. And then I'm just doing my pre-built cached crap to, display this on the browser. So now, yay, we have information. And if you reload it and you actually have a response from Ngrok, you will see stuff, usually your own stuff. But this isn't the interesting bit. We're getting to the interesting bit, people. Now we're going to make it actually respond to DOM changes. So this bit, that's embarrassing. Yeah. So, changes feed. This thing is telling you every time there is an edit in the database, respond and do something with it. In this case, add the message to the queue, resort it. So I reload that locally. I hope people are starting to send messages in, because we're going to see some wonderful stuff in a minute. Unicorns, llama corn. Yes, I've discovered a new thing. There's something better than the unicorn. There's a llama corn. Google it. It's hilarious. Oh, so there we go. We have llama corns. I'm not hearing any applause for llama corn. There we go, one little pathetic one. You know, still nobody loves llama corns, damn you. Right, so we're then going to do the really, really lazy bit. So, we're going to sync this information up. And this is going to mean everybody who sent a message so far is suddenly going to see everybody else's messages. And this is probably going to make me cry, isn't it? Yeah, it's going to make me cry. So, we've got this. We want a remote database. So we want to go to here, which is Cloudant, which it happens to just be remote CouchDB. Dev talks, Cluj, create the database, make sure the permissions of the entire world can attack this database, because I don't care. Oh yeah, let's just take admin. And then I'm going to get the database URL. Strap it in here. So var remote URL would be useful if I remembered to put certain characters in there that allow it to work. Right. So we now have a remote database and we're telling it to sync. Which means if I reload here and start adding messages to the cloud, because that's what all technology is doing, is going to the cloud. Cloudy. Meatballs. I love that movie, but I can't help it. And if we go here, we'll see documents. My documents. Oh, did nobody send me any trolley stuff? Or have they forgotten to refresh their browser? Doesn't work.
It doesn't reload or too many connections.
Right. Okay. I'll be really, really lazy then, and I'll open up another one, and I will just call it trolley. I'm being trolled. Send it. Look, I'm being trolled, and now over here, I'm being trolled. Let's just pretend that the two different tabs are completely different computers. But the wonderful thing is, all this information, we're going to turn off the browser, turn off the Wi-Fi, and look, it still works. So offline data that's trolley. Oh, I'm used to having the trolley statements, and it's kind of ruined my groove. Right, okay, so did everybody follow what I was doing now? Yeah. Does it make sense that you can do really, really quick, dirty, nasty things in the browser with data? My suggestion, never build an IAM client on stage. Right. Get rid of that. Go over here. There we go. Danger zone. So there's the code. I'm going to commit it now in all its glorious, horrible, shonky, bad dev stuff. No error correction or anything. So there's a roundup now. No, I'm done. So that was me. That was all the information. I'm really sorry for leaving you like this. Thanks.
Thank you, Mike, for that talk. It was awesome. I really enjoyed it. I hope you guys did too. It was fun. It was informative. It was awesome. We have 5 minutes now. Mike, don't leave. Don't leave. We're not done with you. We have the Q&A session. Where are you going?
There's a 1 minute warning.
Yeah, but 1 minute to stop talking.
Ah, son of a...
Son of a gun. So who has questions for Mike here? We have 2 questions for him. We can take 2 questions for him. Come on.
Seriously, nothing?
He
Not
was
even about my
really
gifts?
funny. Come on, guys. Nobody.
Are you still with IBM, or
No.
have you founded your own company?
I left Evil Corp and... I now do all the same stuff but freelance. Because YOLO. Cheers.
Okay, one more question, please. Nobody.
Sweet. Peace out.
Thank you, Mike. A round of applause for Mike. Thank you. Don't run. Where are you going? Where are you going? We have a short startup pitch right now, and for that, I'm inviting on stage Paul. Come on, Paul. Come up. And he's going to be introducing Alex, and I'll just leave you to it.
Yeah, I'm fine. Hi everyone. I'll be very, very short. I'm gonna leave the mic to Alex here, and he's gonna tell you about Brainiant. I just want to invite you all to come by the Startup Boulevard upstairs and come by the Ready for Startups area, and I promise you'll get something out of it. Peace.
Hello there. We are Brainiant, and we are giving enthusiasts and developers access to any kind of robot from anywhere in the world. Nowadays, everyone, or almost everyone, knows how to write some kind of code, and the ones who don't should learn. And also, all of us like to play and have fun. Combining these two is quite impossible, since there is little to no interaction between the devices we are programming to the environment. For example, a computer or a phone doesn't have wheels, it doesn't move around, but fortunately we have this environment interacting intelligent devices that you can program. We call them robots. But the problem is just a few have access to these kind of devices, and moreover, almost no one has access to a great variety. Typically, enthusiasts buy their own stuff like we did, but it's expensive and you can buy just a limited number of robots. For the rest, we are watching online videos of what others are doing, or we found a few websites that let you control robots, but only one that barely works. For people like us, the real fun is not owning or controlling a robot, but rather programming it to do really cool stuff. That's why we are building a platform. We're building a platform that will allow users to have access to a robot, write code, and actually see the robot executing it. Developers from around the world will be able to write their own robotic apps or test the hardware to its real behavior before buying it, building the premise for a robot app store. Educational facilities will also have access, so kids or teenagers, students from around the world will be able to learn how to code robots. For the others, they will be, or for the hobbies, they will be able to try this kind of hardware and gain more interest in these devices. So right now we are an early startup. We have the first demo, which is under development, and you can find it at the Startup Boulevard. Me and my colleague Andrei, who are the co-founders of this of Brainiant, we're waiting for you over there, and we'll guide you to control or to program our first 3 robots, 2 of them made by Brainiant and 1 of them commercially made by Mblox. Where is this going? We think that programming robots on Mars or make them accessible for everybody is just a step. Thank you.
Thank you, Alex. It was a great pitch and great good luck with Brainiant. You guys are doing awesome stuff. So up next we have Andrei Crăciun. You already saw him this morning during the panel. So I welcome him on stage. He's a software architect at Avalon SETEX. He's going to he's having a keynote on the theme of From Breadboard to Field. So let's welcome Andrei. Give him a second, give him a second. Welcome and good luck. Oh.
Thank you. Hello. Hi, everyone. I'm Andrei. You saw me. I'm not going to say much about me. So I'm trying to summarize in this talk some of my experience when trying to take my projects, my pet projects, to the real world, the IoT ones. So just a quick question, who here is a developer? Okay, that's great. And who here has played or has intention to play with things like Arduino, Raspberry Pi, Edison, things like this? Okay, that's even better. So IoT. IoT, Internet of Things, is, well, a fancy name which appeared in the last 5 years. Known previously as home automation and everything what had devices that connect or send data to the internet. Still, in this area of Internet of Things, we have solutions such as intelligent braking of cars or automatic braking systems, which actually do not send data right away because you don't want to wait until the cloud, the transaction in the cloud commits to the car, for the car to stop, even though the data is after that probably sent for data analysis. So with products in the space of Internet of Things, humanity has direct and deep interaction. We feel them in ways that we do not feel or do not interact with classic software. There is no big issue if some records have not been registered in a database, which in the end can produce some financial damages, but it's a huge issue if our heating system does not work because of way smaller bug. This makes those projects very present in our life, and the impact for the developers is that we need to ensure that our customers have will feel this and will expect from us to deliver products that do not fail them, because heating systems not working during the winter, it's a big failure for them and affects them. Also, up to now, the customers which we used to are some kind, people that are specialized in an area. If we do banking, fintech, we expect to work with bankers. If we do agrotech, we expect to work with farmers. Medical software, we expect to work with doctors. But for the IoT projects, we work with everybody. So we have to be prepared for this. Lately, on this market, on the developer side, there are, let's say, 2 or we see 3 categories. So on the first side, there are the electronists, guys that really love those things, and they know things about amperes, resistors, intensity, all kind of things, tension. On the other side, there are the developers, guys that only touch those systems through the keyboard. Well, lately, IoT paradigms have brought these two areas, not necessarily these two kind of peoples together. I'm a developer that wants to go through IoT to electronics, and this is why I asked you how many are you, and I'm glad a lot of you are on my side. And for us, there is an ecosystem building for, I don't know, Arduino appeared, I think, 10 years, 15 years ago. How many have worked already with Arduino? So, okay, that's great. Lately, Arduino is pretty basic. So it's, we interact directly with tensions, with analog inputs, digital inputs, things like this. But lately, technologies from big players in industry, and I just named 3 of them here. One is Oracle, Microsoft, and Google, have brought a new level of tools to develop these things. And they promise a lot. We'll see how much they really offer. But what they want to do, they want to take all the responsibility on the electronic side, on the framework, and let the developer just do what they were used to do with the same tools, with the same technologies, and develop new products that interact physically with the world. When we try to develop such a tool, such a product, there is a big difference between when we are trying to play with it or we are really trying to release it. When we're trying to prototyping, we'll probably choose a platform that has a big community, that has a cool IDE. We don't want to spend time using all kind of command line tools. And in most of the cases, we're going to use sample hardware. You know, the ones of you who work with Arduino, it has like 10, 15 form factors. And probably the most common one is the Uno side, the Uno form factor, which has a lot of shields. But this is not very usable in production. On production, we're going to use the mini or the smaller form factors, and this may affect how our systems works. Lately, some producer, and one of them is Intel, it's a big player, they came with Edison and Joule, which they offer the same form factor for both development, prototyping, and product. That's one thing that differentiates a product, a board mainly, a board to be chosen for prototyping versus product. And one other thing is updates. Imagine you have a great product, you have 1 million clients, and you find a bug. You want to update this. How are we going to do this with an Arduino? You're probably going to recall all those devices, update the software on them via USB or whatever, and then send them back, or I don't know, travel to each other customers. Tools for like Android things. I'm not sure about Windows IoT, but for sure J2, ME8 offer this kind of remote update or over-the-air update solutions. So if you guys want to develop things, also please consider this. Just some details on these boards. So there are 2 classes. One class is Arduino Uno, which is very basic, has smaller clock speed, has just a flash memory of 32 kilobytes. You have to be very careful of this when you write bigger software. And on the other class, it's Intel Edison and Raspberry Pi. Intel Edison, it's oriented more on products. It uses less power. It has reasonably well-working 500 megahertz CPU. On the other side, Raspberry Pi, it's stronger. It uses about 3 times the power, because that's important. That's when you develop projects, especially if they are deployed somewhere in the field. Lately, Raspberry Pi 3, I've been successfully use it in a cluster of running on it enterprise Java technologies. So it can run this kind of stuff. So it becomes pretty powerful. This is why I mention it. Okay, now during the years, I've been asked a lot of questions about my friends on how to start it, and they just, added all here. And what may go wrong? What happens if when you build it on the breadboard, when you just put everything there on your desk, and then you go to deploy it? And these are just things that happen to me. So first of it is analog input. Analog input means usually those systems work on 5 volts or 3.3. So analog input means, for instance, the temperature sensors. This is what happened to me. That is for 0 Celsius degrees, you'll get a measurement of 0 volts. For 1 degree, 0.1, 0.2, and so on. And I was building a system to measure the temperature in the house. Everything was working, and I wanted to add a second sensor, which had a cable a length of 15 meters. Well, the tension was, because of the cable was long, the noise was so big, and the tension was lost, it made it so my readings did not work properly. One other thing is I2C. I2C is digital. Digital means you get 0 volts or 1 volt for 0, 5 or 4 volts for 1, and then you get a digital signal. I2C is the most famous one. But I2C devices have addresses. Most of the sensors have those addresses hard-coded. And what's even more interesting, you see that temperature and humidity sensors, usually found this as a bundle, usually have the same address, even if the producers are different. So you have to take care, on the same bus, you can read multiple I2C sensors. That's the greatest thing, as long as the addresses are different. PWM is one thing. PWM is the same thing for output. You just open and close the circuit. For instance, to keep it full open, you have in Arduino 255 times. But if you open and close 128 times per second, the light, for instance, on a LED bulb will be on half. This would be the effect. And you have to take care there of the output voltage, because as you saw in the Arduino, the output voltage is 50 milliamps. So you have to be very careful. If you want to power one of these guys, it's not going to work, and you're not going to know why. Okay, when we are talking about power usage, usually when we develop, the USB is connected, all the power is there. And we go in the field, and we see that after 3 hours, everything dies. The very first thing that engineers do, electronics do on Arduino, they remove the LED. There is a LED there, just take a screwdriver, take it out. That consumes about the half of the power that would consume if you play around. There are 2 things when you see tutorials, sleep mode and deep sleep mode. Sleep mode usually uses 10% of the normal power. The CPU is still running. Deep sleep uses, I don't know, 1,100,000, something like this. It just, and this system work, usually you can put a CPU into deep sleep for a few seconds. So this is how things work. They are put to sleep for 2 seconds, and then they wake up, see for any signals, go to sleep. And you have to consider this. If, for instance, if there's a button, you have to make sure that the user will press that button for 2 or 3 seconds. You want to communicate. Usually, you have something deployed somewhere, and you want to use data. The best thing to use is MQTT. MQTT is something like publishers, PubSub. PubSub, there are brokers, available brokers. Use iot.eclipse.org. This is for playing. It worked for me flawlessly, no matter what the project was. MQTT also has some cool things like QoS. This means how many times and how reliable the message is delivered. 2 is the best thing, is you make sure it delivers the message exactly once. Retain, it says like the last message to be delivered even if the publisher died. And last will and testament is when the broker sees that the publisher died, the connection is interrupted, or it depends how he decides, then the subscriber will receive that message to be notified. Now I'll show you 2 projects I played with, and to show you what went wrong and how could we play it. First, there is the watering system I use. This year will be the 8th iteration, to call it like this. So the requirements were I wanted to, the garden is remote. I wanted to have it to see the status over HTTP, get notified over MQTT. I had 4 channels there, and then I wanted to measure the humidity of the soil. So after I played with it, I had the following issue. Who's going to use it? The user was my mother-in-law. So imagine the pressure. Now she's not a specialist, but she wanted to work, and this should have worked. Well, some years have worked, some years haven't. One effect of not working was a broken water pump, actually 2 of them. So what happened? The water in the reserve was not enough. I used all the water, my system used all the water, and then the pump broke. Then next year, I built a backup system. First in the pump didn't work, the second pump got broken. Then what I built a pressure sensor, and this pressure sensor was measuring how much water do I have in the reserve there, and then I was stopping the irrigation system. This worked. What I didn't do was, and this I recommend you to do, is to, even if the system fails, so usually you need 1, 2 backup systems. Some guys told me about they're building a lunar system that it needed to be for each small system to have 3 backups. If one fails, to hold the other, and so on. It's pretty hard to go there and change it, so this is the reason. Usually it's good to have logging. You'll have iterations and to have analytics to, not to, I don't know, to analyze it with specialized tools, but for you to take a look what went wrong, because usually you're not there when it happens, you just see the effects. Another system I wanted to build, I wanted to try Android things. When Android things appear, me and a friend of mine, so we are promised to develop things quick and easy. We said, okay, we're going to build it in a few hours, a monitoring system for a beehive. We took a scale, just a regular scale, and then we are going to put it under the hive, and with a Raspberry Pi or an Intel Edison, which was running Android things flawlessly. This was promised. Just get the data, put it in a Firebase database, and then see it on a smartwatch. This was just the plan. What happened? So first of all, beehives were remote. We needed to somehow have connection to a cellular network. Raspberry Pi and an Intel Edison does not have this. They have Wi-Fi. What we did, we bought a router which has both 3G and Wi-Fi. But there we need a special card, an M2M SIM card, which are exactly the same but resist better in harsh conditions. Then we realized that the router is not IP67. So you see this IP and 2 numbers, 68 is the bigger. First is, I'm not sure which is which, but one is resistance to water, the other is resistance to dust, and you like to have 67 or 68. Basically, you can put this into water. We had to build the box for the router. We needed power for the router. Raspberry Pi was running enough on batteries for us, but we needed power for this, and we added a solar system on this, a 50-watt solar system, and then we started implementing it. And we need drivers for what is called HX711. You don't have to know this, but it's basically an amplifier for the cells, the load cells in the scale. In order to read this, you need a driver. The protocol is simple, just a few bytes to be read, and then we implemented it, didn't work. Just move a little to the next slide. This is a capture from an oscilloscope. If we didn't have this, we couldn't do it. And this is something that electronics have. So sometimes you cannot go on this side. So what happens here, you'll see that this is ones and zeros. This is a zoom for this. What happens? This 1 here and 0 was actually telling the device to stop. This is something that Intel Edison does, running Android things. Until at this point, we've done this project beginning of this year. We do not have an answer from Google. We asked them, or from Intel, and they say just happened. So it's a bug somewhere. But if you didn't have this device, then probably things won't work. Also, one other thing, it's about testing and timing when we test. So we tested this device during winter. During winter, you cannot work with the bees because they'll die, they'll freeze. We wanted also to have humidity and temperature inside the hive. So we built this sensor. After some time, it didn't work. This sensor, if you see there, everything around there is wax. So some period it worked, and then it didn't work. The bees did that. We logged every time, so we kind of had the analytics, but we do not know what actually caused this. Okay, since my time is up, just want to share with you some resources. These are places from where I buy tools to play, and I'll open for questions.
Thank you, Andrei. Let's give him a round of applause. And this is our favorite part, the Q&A session. So let's see those hands up. Come on, don't be shy.
You mean like Arduinos, Raspberry Pis, things like this? It's not usually easy. Some of them have, they work between them. So the question was how easy it is to combine these systems. Usually you need to have protocols like Bluetooth, Wi-Fi. Serial works sometime, but it does not work between all of the devices. You need to carefully take which devices you choose. You need to carefully choose. It's not like they are fully compatible. There is a certain level of compatibility, but not fully.
On the hive monitoring system, you said that you use the router to give internet access to the internet user, I think. Do you find it more beneficial to use a router against using a GSM shield?
For the GSM shield, I needed a driver on Android things, and didn't have it. This was the reason. Yeah, I would have loved to use the GSM shield. That would have been the better approach. You're right. But we had to build a driver for that shield or for that modem in the end, and we didn't want to do it. So yeah, this was the fallback, to call it like this.
Thanks.
Did it happen to you to have to restart the device while it was in production and
remotely? It died. A lot of my devices died. Yes, I only once built a system for a device to self-heal, to call it like this. But the cool part is that device never needed that system. So, or it worked so well, I never had, C logs, it well. Once I built a system on the watering system, actually the last year, was built using Edison, which is, you have to work heavily C with things at a low level. I developed it with a framework that was running in JavaScript. I expected to crash, I don't know, I think it is, but it worked flawlessly, all the summer. My mother-in-law was very happy. So.
Just one question. How easy is it to access it remotely if you have an internet connection for such a system?
You, for the smart ones, for Raspberry Pi and Intel, you basically have a SSH connection. For the others, you have to build it yourself. For Arduino, I was actually adding an HTTP library to have a TCP stack on it.
And if you add in, let's say, communication through HTTP on on an Arduino device, and it uses the port 80, I tried this on the device and I couldn't access it remotely from another internet connection. So I added it in the router, and I was thinking if there are other steps.
No, for me it worked directly. I just took the examples in the Arduino IDE. So it worked, and even it worked. I once had a project that 2 lights in my house are controlled only via HTTP. And I was remotely, just again, my mother-in-law is the actor, she was with my daughter, and she wasn't answering the phone, entered and turned on the lights, and then, so it works. It may be something, some routers do not accept some internet providers, you have to take care to have this forwarding thing, and then it works. Yeah. Usually, for me, it worked directly, so, but we can discuss after if you.
Okay, that's fine.
What advice could you give for moving to manufacturing your own PCBs and even further to using SMD components?
So,
because otherwise you are just stuck with a giant mess of wires between independent.
There are two things you need to take into consideration. If you want to build things that have less power, do specific things, then you have to build your own. If you want to sell this, you may need a certification for that device, especially if it has some wireless connection. So it's a trade. That thing costs. So if you want to build it for yourself, for instance, FCC allows five boards of the same type to build it for yourself. If you want to go deeper, yeah, I'd say to go there. Me and some friends, we also work to a startup in beekeeping, and after 1 year of test, we are at the level where we have to build our own board. Yeah, it's to have a custom board. So if you can do it and you think you need it, go for it. The main reason is power. That's the first reason.
And if I want to do this, where should I start? What advice would you give?
Where we're starting, we usually start with what Arduino has in it, the Atmel CPU unit, and then we move forward. For instance, sometime we needed some RF communication, and we went for Nordic. You know those guys that made that NRF? They have some boards. Usually, you don't want to work a lot. This is what I saw. So, depending on the project, the board has to be chosen. There are some guys, I'm not sure if they're in the room, that developed something for the greenhouses, and they said they went for Texas Instruments board exactly for the same reason. It fits their needs better. So there are a lot of options. Do not try to really stick everything in there, because you're going to lose time. If you can take something, take it.
Could you also recommend services for printing PCBs?
How we do it with the old classic laser printer and ironing on the back. But there are services. If you want to go with big numbers, these are located in Shenzhen in China. They have a service. I haven't tried it personally, but somebody told me that it works pretty good. But the price related to other providers in China is 7-8 times. Still is very cheap.
Thank you very much for answering the questions, and thank you guys for the questions. Andrei, awesome keynote, and let's give him a round of applause. Please just stay put for 5 more minutes. I know everybody's hungry and they want to grab a coffee. The lunch break is coming soon. Meanwhile, I'd like to welcome on stage Paul again. He's going to be introducing the next startup pitch. Thank you.
Thanks very much. So I know lunch, keyword. So it's just going to be 3 minutes, promise. The next startup is about machine learning and money. So stay tuned. Georgia, please, to the stage.
Thank you, Paul. Hi, I'm George Olteanu. I'm representing my company, MI7 Plus. We are a new startup built around the financial markets. We are trying to be the most comprehensive risk management service for traders around the world. And we provide our service on a subscription basis. Basically, we've built a series of algorithms and mathematical computations around the factors that really drive the financial markets. So this product that you see up there is available for traders on a subscription basis. We have validated the product with experts in the field, one of which became our partner. He's a Wall Street trader, a very successful Wall Street trader. We have validated the product with several brokerage firms and successful analysts, like analysts from Vanguard, those of you who know Vanguard, the investment firm. What we need right now is to partner with someone who is specialized in machine learning. What we want to do is use our data sets and implement a better algorithm on those data sets. What we made with machine learning is basically very crude, and we want someone who has more experience than us in that area to help us out. What we want to offer anyone who is interested in collaborating with us is not a job per se. It's actually a partnership. You can work remotely on your own time. You don't have to quit your job or anything. And you won't get a salary. You will get royalties from our subscriptions. We hope we will try to make them inheritable. So basically, on $100 subscription, that's what we charge. Maybe you can get like $5, and in 1,000 subscriptions, you will get $5,000 for the rest of your life, basically, if you implement what we need. Other things that you might find interesting working with us. We are a team of experts from different fields. So you will get to learn a lot about geopolitics, macroeconomics, and the financial markets, statistics, and stuff like that if you stick around with us. So anyone who is interested, we ask you to contact us. Visit our website, mi7plus.com. Everything is explained there even clearer. And we have a booth, a stand on the first floor where we can talk in more detail. Now, if you are interested in brand new startup in AI FinTech, we can talk more about it. Any questions if you have, you are welcome to address it.
Thank you, George. If you have any questions, you're welcome to catch up with George in the lunch break. Regarding the lunch break, I would like to encourage you to walk around, test our product, see our booths, and most of all, we have a pretty cool thing that is called the sugar wall, where we have small little pockets for all our speakers. So if there's somebody in particular you want to send a message to and you want to tell him something, you can go there and write him a message and put it in the little pocket. This being said, thank you very much and see you after the lunch break. Enjoy.
that's what my next step was. I was learning how to use CSS and how to extend them with XPT formats.
Are you interested in any tips? Like you said, Sourclass, that was an amazing choice for G divisions.
It's one of those things where I was very good at
Selling it, okay. Yeah.
I just have my face in front, right?
Right, that's possible.
Oh, no, oh my god, I did it until break. I got break last night. I actually used the background website.
I would like to see some of those, yeah.
I'm so proud, so proud.
I can imagine, I can imagine. So, welcome back everybody. I hope you enjoyed your lunch break. I saw some of you with some huge plates of cookies, so I hope you enjoyed it. Before we begin, I would like to remind you once again about our sugar wall. It's the wall outside where you can go and leave messages for our speakers. So if there's somebody you didn't get to talk to and would like to leave a message, you get the chance to do it now. Also, I would like to kindly ask you, if you have the time, we should have somewhere on the screens a link that you can access to if you want to leave us some feedback about the conference. We would really appreciate it because this way we can make the next year's conference even better. Next up is Martin Split. He will be replacing Wana Kalugar, which from personal reasons could not be with us here today. Therefore, I welcome on stage Martin Split. A round of applause, please. I think I'm actually going to leave Martin to introduce himself. I said I would, but I think I lied.
Thank you very much.
He will be talking about web VR, about the whys, the what, and the hows.
Yes.
So there you go. Good luck.
Thank you very much.
Enjoy it.
Thanks. All right. Sweet. I'm very sorry that I'm not going to talk about mobility as a service or something like that. That's not my cup of tea, but I hope that I can throw some eye candy and interesting inspirational things at you in the topic of web VR. So, and now my clicker stopped working. No, there we go. So, who am I? Well, my name is Martin Split. I am the head of engineering at Archeologic. Archeologic does these wonderful things. So this is in the browser, a 3D model that you can interact with of space, be it your home, your office, or a event hall like this that was in Vienna. So you can then also furnish them and basically experience them and try them out and communicate about them and share them with just a link. Now, that is very cool, but that's not all I'm doing. I'm also a Google developer expert for web technologies. I am working or help the Mozilla community to spread the word about the cool stuff that they are doing. I generally really try to get the open web forward. And basically, I invite you all to contribute to the platform as well. Before we start, let's have a look at the VR landscape as is right now, because VR is like a super hyped topic, but all the hype is very loud, so sometimes you can't really get like the small details and small nuances. So let's have a look. So I picked the most common VR devices that there are in the market and their capabilities. So I picked the Oculus Rift, the HTC Vive, the Gear VR from Samsung, the Daydream from Google, and the Google Cardboard. These 5 devices are pretty much the market when it comes to non-gaming console VR, and they, as you can see, have very wildly different possibilities. So for one, and the most obvious one, is 3 of them are mobile, the other 2 aren't. So the HTC Vive and the Oculus Rift are made for desktop experiences, while the other 3 are actually kind of more on the go. But these mobile devices have one big downside. They have no idea where in the space you are, so you can't walk around because the phone does not know that you're walking in a certain direction. It might get this accelerometers to figure out that you are walking, but they can't track you in the entire room. The HTC Vive can, and the Oculus Rift for a certain degree of can as well. So that's the room scale, for instance. Another interesting difference between all of them is how you can interact with the content you are in. So if you are in a VR application, how do you interact with the contents? Well, the Oculus Rift and the HTC Vive have controllers that you have attached to your hands. So you actually have like 2 hand gestures, and you have like lots of buttons and touchpads and things. So you have really rich interactions, and it feels relatively natural. However, on mobile, we are not that well suited. So for instance, the the Gear VR has a little touchpad on the temple, so it's a bit awkward. You have to kind of like do this and then scroll and touch and click things to interact with 3D content, which is a bit weird, but it's still pretty good compared to the cardboard that has literally 1 button. So you basically have the mouse click. That's the maximum you can do, right? And then in the middle of that is the Daydream device, where you have a pointer that you can take into your hand. It has a touchpad and buttons as well. So that's quite a bit of a difference, really. And it's really hard to develop for multiple platforms because they are having wildly different requirements for what you can do with them. So you might want to ask yourself, so what platform should I go for? What ecosystem should I go into? And let's look at last year's sales then. So the Oculus Rift sold approximately 350,000 units. If you saw any forecasts, that's by far not what was predicted. So there is a certain hype attached to it. So we have the Oculus Rift. We have the Vive is slightly more successful in terms of sales, a little more than 400,000 units sold last year. And then we have PlayStation VR, just for reference. So that's attached to a PlayStation, Sony PlayStation. And there's approximately 750,000 units or 700,000 units sold. So that's really nice. But what about mobile? Well, let's have a look at the Gear VR and the Daydream. So the Daydream is a bit behind, is a lot behind because it only came out in, I think, August last year, and there's very few phones available to this date that actually support it, but we're gonna see a catch-up game there probably. But definitely the Gear VR is outselling them all by lots, right? I mean, that's easily 2.2 million devices sold. So 2.2 million devices compared to 400,000 devices, or 800,000 devices if you want to compare with PlayStation VR. So mobile is selling really well. But we haven't talked about cardboard yet. That's a bit of a difference. That's 88 million cardboards out there. And cardboards are really, really cheap. If I would have known that I would be talking about WebVR, I would have brought some as well. But cardboards are really, really cheap. Well, cardboard devices that you fold together and put your phone in, so you use your phone as the VR display as well, as you do in the Gear VR and the Daydream. They're really cheap. You can get them for €3 from China. So that's not really a hurdle. And it works with pretty much every phone, including iPhones and stuff. So the Gear VR only works with certain Samsung phones. Daydream works with certain Android phones, but cardboard works with whatever you throw at it. Obviously, if you use an old Nokia, you're not going to have a really great VR experience, but you could try. It's definitely going to look interesting. So if we look at the landscape, the conclusion is that we are dealing with very different capabilities. So if I'm building for the desktop case, I can expect the user to want to walk around in the room, and you have to account for that. So it's a standing experience. People stand and walk and move themselves physically. Whereas on mobile, I'm having more of a sit-down experience because I can't really move, so why would I? It's a bit awkward to just stand there and go, right? So you want to sit down and do the same thing, which is as ridiculous looking, but it's still pretty fun. And mobile definitely kills it in the market. So I did not predict that, to be honest. Yes, sure, mobile is everywhere, blah, 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 but I thought for VR, you want the high-end experience and it would sell really well. It doesn't. In hindsight, that wasn't a big surprise because obviously you have to have hardware that supports your desktop VR experiences. Not everyone here. Who here has a gaming PC that was built in the last year? Look around you and you'll see that we are not the majority. So yeah, mobile VR is by far selling better and by far more widespread. And in mobile VR, the cardboard is the baseline experience. It's not something that very few people have and it's like, the thing that no one wants. No, it's a thing that basically is everywhere these days. It's widely spread, and that's probably not going to change too quickly. But okay, that's nice and fine. So we have a really fragmented fragmented landscape in terms of ecosystems and in terms of capabilities of the devices and high fidelity of the devices. But why would I even care about VR? There's a bunch of things that people who are totally on the hype cycle say. It's like, oh, it's going to change how we experience shopping, or it's going to change how we do our taxes, or how we do spreadsheets, or how we do, I don't know, yeah, whatever, entertainment, let's put it that way, games and other things. And I don't think that's the two, or that's the really large things. I think two other things are actually much, much more interested and much, much more geared towards being successful in VR. One is the creating experience, here exemplified by Tilt Brush. So Tilt Brush lets you draw in 3D. So that means that you are in a space that has no gravity or physics, really, and you get to draw whatever you want. You can draw with fire, you can draw with water, you can draw with things that respond to music. So you can create the world that you want to create. You are in an empty black room, and then you get to fill it with life, whatever that life is going to be. And it's relatively intuitive. I have seen a lot of kids trying it out in our office. They really enjoy just, putting things together and then building interesting experiences from it. So creating content, creating something that you can't do in real world circumstances. I can't really draw with fire, and I think my wife would not like it if I would be carrying lava into our flat to build a volcano. She might have a word with me about that. So this is where you can go crazy and do amazing things. The other thing is experiencing things that we can't, for whatever reason, experience in reality. So here we are having a kind of extreme Spider-Man move coming from space into, I think this is Tokyo. So that's really cool. That's Google Earth on VR. There's other things as well, concerts. You can sit in a concert where you can't go. You can do all sorts of funky things. You can fly into space. You can snorkel the Great Barrier Reef, which is something that is maybe not possible for much longer, unfortunately, thanks climate change deniers. So yes, you basically get to experience things that you can't experience. And that's not necessarily a niche thing. If I am in another continent and I'm about to move to a new continent and I have a flat to visit there, it is relatively expensive and complicated to actually just fly in for a flat visit, for an apartment visit, but I need an apartment. So how about, pictures, nice and fine, but I think if I get the possibility to see the apartment around me as if I would be standing there, that would be better than photos or videos can ever be. Because you get to experience how the space feels, how the lighting feels. It's not distorted by pictures. Because if I take this room and I take a picture from the lower end of that corner, the room is going to look gigantic. If I do it slightly different, it's going to look tiny and cramped. So pictures are not really good. Two-dimensional images are not really good to convey three-dimensional spaces. Also, if you have a fear of flying, it is relatively complicated and expensive to cure that by going into airplanes and experiencing the entire boarding experience and getting through it. And basically, at the early stages of a therapy, you might enter the plane and go, nope, I can't do that. That's really expensive. That was really expensive 20 minutes, I guess. With VR, you basically have the same feeling that you're in the plane and you hear the noises and it's stressing you out just as much. Trust me, it stresses you out. But you can just go, nope, breathe in, breathe out, and go back in. So that kind of is an interesting thing for therapy as well. Not just that, it's also customizing things, like customizing your car is an interesting experience in VR because you get to try it out from different viewpoints as well, and trying it out kind of virtually, which is nice as a first step. It's not going to replace actually sitting in a car and taking a test drive, but it's actually a nice first step. It's an additional first step that we can't have right now. Also, I have a relative with social anxiety, so he does not want to expose himself to the outdoors, like other people. We all know that feeling, right? But for him, it's an actual condition. He really can't. Even if he wanted to travel, it puts a lot of pressure on him mentally. So he had been living off of family photos from other people traveling the world. But it's kind of like you have this tiny, tiny window into other, even if you put it on a screen, you have this window somewhere on the wall that you peek into. But if I give him photospheres, which is basically a 360-degree panorama of where I was, for instance, when I was on a mountaintop or something, he loves it. He absolutely loves it because he experiences it. Obviously, it's not as good as standing on the mountain and feeling the wind and stuff, but for him, it's the best he can get. So it enables people to experience things they can't experience for whatever reason. So that's really cool. So sharing and experiencing. And also the intuitiveness of the interfaces, so you get to kind of walk to a thing, you get to draw a thing by actually moving your arm. So that's an interesting thing because it has a very low barrier of entry for everyone. We are really bad with interpreting 2D images of three-dimensional spaces. That's an interesting use case. And sharing experiences and collaborating on things together. So if I can't, for some reason, hang out with someone and work on something together, VR is a good emulation. But this is really important, so sharing experiences. But if we remember the VR landscape, it is very fragmented. So if I own a HTC Vive and you own a cardboard, how does that work? How do we share the experience? If I'm like, hey, try out this app, and then you're like, so I get a $600 computer, and then I get a $700 VR headset. Not really, it's not going to happen. So what if we put it on a platform that I think everyone more or less has access to? Who here has a browser on their phone or computer? A web browser. That's really good, because now I know exactly who's basically just checking emails, and that's fine. But yeah, so every one of us has a browser. So how about I give you a URL, a link. You click on the link, and then you see something. Maybe not in VR, maybe you get a 3D thing that you can walk through first, and then you're like, oh, this is really nice. And then you put it on your phone, and then you put your phone into your cardboard, and you're like, ooh, this is nice. So that's an interesting thing, and I think the web is the perfect platform for sharing and collaborating, because that's what it was built for. It's the platform for this. So, you know, someone thought, so we have VR, and we have the web, now KISS. And a lot of web developers that I talk to are like, whoa, no, I don't want to learn new things, and oh my God, VR, and like 3D is complicated, let alone VR. So they're not really fond of that kind of thing and mindset. So I prepared a little live coding to show you that it's not that hard to get started. And I'll sit down for that because I'm a lazy bum. And we'll write something together. So can anyone not read this? If you now nod, come closer, there's plenty of seats in the front rows. Try it out. So I'm using a library called A-Frame from Mozilla. And it is a website, right? It's not like funky, complicated stuff. It's a website, and I can open that website, and the website I get is saying hello web VR. And just to prove you that I'm not fooling around with you, I can also say like Dev Talks, hello Dev Talks. And if I refresh the page, surprisingly, it says hello Dev Talks. I know it's shocking. But we also have this A scene here, and that's where all our 3D content will happen. So what is it really? Well, let's try it out. Let's say I have an A box, and it has a color of red. And I position it. Now I have to think in 3 dimensions. So the first coordinate is how much to the left or to the right. I don't want to move it to the left or to the right. The second coordinate is how much up and down do I have to do. I don't want to do that. And then this is how much into the space or out of the space do I want it. So I want it, let's say, -5 meters into the space. So I declare this to be meters. And now if I go back and refresh, oh, look at that, there's a red box. And out of the box, I can also just walk around the box and experience what it is to have a box. It's not really exciting, is it? But, you know, I have a box. That's not a bad start. Let's get us some sky around this. Let's use an image for this sky. So what do we have here now? Oh, look at that. There's a floating box on a mountain. It's a bit weird for a box to be on a mountain, but that's okay, I guess. I can deal with that. Also, it comes with that was the wrong key combination. That was interesting. It should come with why does it not like me anymore? I might have installed a program that does window size management that overrides one of the shortcuts of, okay, that's funny. Give me a second, I'll kill the program so that it does not interfere with my demo. Bastard. Right, so here we have it. We have a key combination to get into what's called the inspector. It's kind of like the DevTools, but for 3D content. That's really cool. So here we see our sky around us. We see our box here, and I can click on the box, and I can move it around, and I can move it up a bit, maybe, for instance. I could go in here and change its color if I wanted, so let's make it the green box, because green is nicer and friendly, I don't know. You figure it out whatever you want. And then I can add new things. So for instance, I can say, I want a, I don't know, sphere. Why does it, am I blind? Oh, there it is. Here's a sphere. So I can now create a sphere. I can make it larger. I can click here to make it larger and then say, ooh, okay, this is funny. I have no idea what I'm doing, but it looks fun, I guess. And then I can go back into the scene, and there's my sphere. My pink sphere is right there. My green box is right there. I can export that. Hurrah. That's nice and fine. Ooh, and it has like super funky graphic issues on my Mac. That's fine. That was planned all the way. I can also go into full screen. So this device does not have any VR hardware, so I can't really experience it, and the sphere just pisses me off. I'll just remove it again. Go die in a fire. Wait, what? Oh, I just removed the geometry. That was interesting. How many did I create? So that's why it was flickering, because I created a lot of them. Right. One day I'll have them all gone. Ah, there we go. So that's nice and fine. Sweet. I can't experience this in VR, though, unless I put in a device that has VR capabilities, such as my phone. It's not a Pixel phone, and yeah, no, I don't want to access files on it, goodbye. It's not a Pixel phone, it is a ZTE Axon 7, and I went into the completely wrong thing, and I need my dock to appear. Inspect, and if I go into the browser, tabs should appear, and I might have to re-forward things, or reverse things, so that I can actually access the thing. So here we go. All right, so here's my website. That was the old version before I reloaded, and now I'm going to reload. And here we go, right? And you can already see if I move my phone, it moves the camera as well. And if I go into VR, it renders for a VR headset. So this is now a VR experience. And if I now have a cardboard, for instance, or a Daydream device, I can pretend that I'm standing on a mountain and scream like a baby because I have a really bad fear of heights. Besides, so just to prove that it can do VR, it can do VR. Surprise. But besides that, we can also do other things. So, I mean, this was not very exciting because we basically only had, do I have this file? Does it exist? I don't even remember if yes, okay, this file looks a little nicer. It was basically prefabricated or made things like boxes, spheres, rings, cones. That's not really exciting, but what I can also do is I can say I have assets. So if I have friends, I luckily have a bunch of really, really clever people that can actually work with 3D editors. So I get to do this, was it model, export GLTF. So we created, using our tool, or a good friend of mine, Madlina, created this wonderful model of a building, and I can now go, I want to load this GLTF. It's a format, it's a 3D format. Think of it as the JPEG for 3D on the web, all right? So what I can do then is I can load the thing that I should give it an ID as well so that I'm able to actually, let's call it building, to access it. So I'm going building now, and if I'm reloading here, ta-da! I have loaded an entire building, and I can just explore it now, right? So there's like some furniture here, and if I remember correctly, oh yeah, because Madlina is awesome, she has made a model of the model into the model, just because why not? Round of applause for her, because I think that's amazing. Just because she could. So, yes. So that was that. That didn't hurt, did it? And I think that was reasonably fast and reasonably nice. I'm not going to get out right now because I unplugged my click. You know what? I'll be nice. I'll put my clicker back in. So here we go. So Why should you try out WebVR? Well, first things first, A-Frame makes it really easy to have a go, as we have seen, right? There's much, much more. There's animations, there's loaders for all sorts of formats. There's a lot of really cool stuff in A-Frame. It's available on many devices and platforms, so it works with HTC Vive, Oculus Rift, Gear VR, Facebook VR, like the Facebook Home thing. It works with everything, basically. It will soon start working with HoloLens and Edge as well. Samsung's working on it, Mozilla is working on it, lots of browsers support it. And those are the browsers that support it right now. This here is Samsung Internet. And this is Carmel, this is the Facebook browser, the special new thing. This is Servo, an amazing experimental browser from Mozilla. They also have it because, you know, you have to have WebVR if you're a modern browser, right? Note the one browser that's not on the slide. Just saying. It's an open standard, so everyone can contribute. And right now, it's a lot of browser developers, and it's a lot of people who work a lot with VR, but we need all of you, all of the people who want to get into it, all of the web developers and people having websites that want to do VR. You have to try it out and tell us where it's failing, because we need your feedback really badly. There's lots of tooling and there's a really strong community. So if there's a WebVR Slack, there is a A-Frame Slack, there's tons of tutorials and forum and blog posts. So if you Google for A-Frame, you will find a lot of material. And everyone's super friendly and trying to help you. This is really cool. And it's so easy to create and share. I can do this kind of thing, upload my files to anywhere that accepts static web hosting, and you can experience this by just clicking on a link. And I find that really cool. There's a few challenges that I don't have time to go through, but one is like natural input is not naturally in VR a good thing. So here we have a bit of a frustrated user. You can use this kind of pattern, so figure out where a user is looking at and then using that to interact with. So gaze, gamepad VR, leap motion, yada, yada, yada. Slides are going to be online. Moving in VR is a bit of a trick, because what if the space is much larger than the real space you have, or if you're on a cardboard? Well, here's a kind of ninja thing that I find funny, but it doesn't work with cardboard, but it's pretty cool still, teleporting you like that. You can fake a lot of emotions as well, so this is all fake, like the eyes are predicted based on the direction you're turning in and stuff, and the hands are predicted as well based on what happens in the scene, but it makes it feel like this user is actually like, there's no hand tracking involved. This is all fake, but it makes you feel like it's natural, doesn't it? There's a virtual VR hackathon until end of June. You should get on that, because it's amazing. It's done by Ada Rose from Samsung. You can win a Gear VR, I think. Highly recommended. The motto is VR together. Try it out. Build something with A-Frame, show it to people, get feedback, and hopefully win something. Then there's Steve Jobs was quoted with saying that humans are great because we can use tools, and the bicycle actually allowed us to get far better at things that were like physical movement. We are not the fastest animal on Earth, but if you compare like energy usage to speed, the bicycle really kicks us on the front of it. But the computer is kind of that for our brains, because it enables us to do clever things. Like, I'm super dumb, but computers enable me to do cool, interesting things and get me on stage here. Hi. And if the computer is the bicycle for our minds, I think VR is the teleporter, because it gets us somewhere where we can't go and gets us doing things that we can't do in real world. And I think that's amazing. Thank you very, very much.
Thank you, Martin. That was
You're
a
welcome.
really, really, really awesome speech. Like, it was great fun. We have time for two really quick questions for Martin. So, who wants to start?
I'm also on Twitter, and I'm around the entire day. So if you want to talk to me, just find me. I'm a nice person, and I have Swiss chocolate.
And he has a unicorn suit.
Not here. Disclaimer.
Yeah. So, anybody? Any questions?
There's
yeah,
one question
back there.
What are the performance concerns when rendering on the web? Yes. The same as on anything else, because basically the browser allows you to directly go through OpenGL. So there's not much in the middle of that. It's a little slower, but if you run into that, then you might run into it anyways. You're welcome.
Okay, one more question.
Everyone's like, what has happened the last 30 minutes? Where am I?
What's going on?
Who
Okay,
am
so
I?
it seems you're off the hook.
Thank you very much.
Thank you very much.
Thanks.
It was awesome, and keep in touch. Okay, next up, we have Marcel Creme. I think you guys know him from the panel this morning. He will be talking about a multi-level approach for automatic document classification. So give a round of applause for Martin. Thank you again, and welcome, Marcel.
That's really good.
Okay, guys, are you ready? Woo! Good luck.
Hello. My talk is about natural language and classification. At 8x8, we build product for call centers where we have calls that are transcribed, and we analyze the transcription in order to find interesting topics. So this is the idea of my talk. My presentation is structured like this. First, we will define the problem. Then we will talk about existing approaches. We'll see the solution that we propose and some conclusions. This task was a special task for me because it's a different kind of research comparing to the research I did in the academia. Because here the time is very limited, and we need to find quickly a solution that works and satisfies the client. Now, in order to define this problem, so our data consist in call transcriptions. And the goal is to find some relevant topics in the large amount of call transcriptions. These topics are defined by the user. Maybe a topic may be anything. Basically, it's a sentence. For instance, some user may want to cancel their account. And a topic may be defined by a sentence like, I want to cancel my account. Or maybe other clients have problems with their phones. And the topic will be, I cannot make phone calls. And our goal is to find in a large volume of transcription the calls that are related to such topics. Now, why is this problem a difficult one? Basically, everything is related to natural language is a little bit tricky because natural language and computer language are two different things. Another aspect that makes the problem difficult is the fact that the topics are not known before. For instance, if we have sentiment analysis, in that case, we know before what are the topics, the classes. But in this case, a topic may be anything, any sentence. So the problem is more difficult because of this. Some topics may be very similar. So how to discriminate between very similar topics. Or we may have a sentence that belongs to multiple topics. Obviously, we started to study what are the existing natural language processing tools, because our intention was not to invent something new, but to find something that works. So we studied APIs produced by Stanford, MIT, and the others. But however, we tried to start with the simplest approach and not go directly to the most complicated one. So the simplest way to try to solve this problem was to use regex. It's very basic. However, we do not want to let the user write the regex expression because it's too complicated. Instead of that, we use it in the backside, and for instance, in this case, we are looking for sentences that contains the same words as the words that define the topic, in the same words in the same order. Well, such an approach will match, obviously, all sentences that contain the same words, even if some other words are between the words that we are looking for. But such an approach will not match, for instance, situation where a word from the topic is missing. Also, will not detect the negation, for instance. Well, with the regex approach, there are some advantages, but a lot of inconvenience. This approach is very fast. It's clear. And it's language independent. This is an important advantage because we may have transcription from different languages. Well, the result is obviously binary. It match or do not match. And if some words will change the significance of the sentence, regex may match, but will not find that words that change dramatically the idea, for instance, like a negation. And there is no semantics, obviously, with regex. A more flexible approach is to use lexical distance between words and sentences. Lexical measures are based on the concept of sets, considering that a word is a set of characters and a sentence is a set of words, and we can define distances. For instance, Jacquard coefficient is the fraction, the report between the intersection and the sum of the set A, B, and minus intersection. Well, with such an approach, we have a fuzzy matching. This is an advantage because sometimes call transcription may contain errors, some spelling errors. So it's important to tolerate some fuzziness for the matching. And such an approach will match, for instance, this topic. I want to cancel my account with I want to cancel my account right now, or I want my account to be cancelled. It's not exactly the same word, but it's a part of the word, but will not match the same idea expressed with other words because it's not semantic aware. So basically, as a synthesis, the lexical-based approach is language independent, is fast, work fine also for fuzzy matching, but it's unaware of the semantic related to the words. Another approach, more advanced, is to use a dictionary, because in a dictionary we have synonyms and we have relation between the words. And we tried this approach. There is a website where you can test examples of words and sentence similarity. And with WordNet similarity for Java, for instance, I can compute a matrix that contains a similarity score for pair of words. Also, we can observe that there are some notation. For instance, the verbs, the nouns are detected. This part is called part of speech tagging, post tagging. Well, the problem with this approach was that we do not have a global score, we have a matrix, and maybe we need to compute just one global score for a pair of sentences. But this can be solved, for instance, if we take only the verbs and the nouns, and we consider the similarity for the verbs, similarity for the nouns, and we are making an average. So it is possible to compute a global score. However, these tools may have some limitation because the post-tagging is not perfect. In this case, I love this service, I like this service. The problem is with like, because it's detected as a preposition, and since we are looking only to verbs and nouns, we will not take in account that like. In conclusion, the dictionary-based approach is better than a lexical approach because it is semantic aware, and, for instance, will match some sentence like, I want to close my account with want to cancel my account because of the synonyms, but will not match the same idea expressed with completely different words. This is still a problem, and will also match sentences where we change the meaning of the sentence, for instance, by introducing a not. So it's semantic aware, but not logic aware. Also because most of these approaches are eliminating the so-called stop words, like I, not, and. Okay. So in summary, the dictionary-based approach adds the semantics level, works well for synonyms, but we still have a problem to extract the meaning. In fact, I discovered that this is a main problem of the natural language processing, expressing the meaning, what the meaning is. It's difficult to define the meaning. And will not detect also expressions. If I'm saying the same thing, but using an expression instead of a word, will not detect such a situation. And as we have seen before, the post-tagging may be not so good for some examples. Well, we tried to see if there are some other approaches. And we found that neural networks have been used for this kind of problems. For instance, this kind of architecture called long short-term memory, discovered or invented in '97, then improved and used recently, for instance, by Google Translate, may also be used for topic classification. I found some Python implementation that uses Google News database, but the results were not so good on our call center specific topics. In principle, with a neural network, it is very important how the data looks and how they are trained. Because, for instance, if the data if you have two classes and we have linear separability, one neuron can solve that problem, but if the data are very mixed, we need a much more complicated network. Also, if we train the network with a set of data, even if a neural network is capable to generalize, this capability is limited. So we observe that if you are training for one domain, when we change the domain, the results are not so good. Another approach that is also related to neural networks is word-to-vec and paragraph-to-vec. The idea is that if we want to give as input a sentence to a neural network, we need to represent that sentence as a vector. And for instance, you have this API, Deep Learning for Java, where you have an implementation of word-to-vector and paragraph-to-vector approaches What this means, for instance, for word to vector, some training data is used to determine for each word a vector in such a way that words used in similar contexts will be one near another in the vector space. And paragraph to vector is a generalization of word to vec. Behind this model, there is a probabilistic function that is conditional probability to have a word after another word. And we found an implementation, and we tested this approach to see how good it is for our problem. And the conclusion was that it works better than the semantic approach for some cases. For instance, we'll match sentence like, I want to close my account, or please close my account, but we'll also match some false positives which should be eliminated. For instance, if we have topics very similar, like let's suppose I have a topic, I have a problem with my phone, and another topic is I have a problem with my fax. They are very similar, but I would like to make a discrimination between phone and fax. And this kind of approach is not very good to discriminate very precisely between sentences where a word can change the meaning. Also, this kind of approach will not detect the so-called natural logic. For instance, when I use not, the idea is different, but the sentences are similar. However, it depends what I want to detect, the idea or the word similarity. So, as a synthesis about this kind of approach, there are some advantages and some limitations. We have the semantics at the word level. This, of course, this neural network may be retrained and will become more intelligent if we are retraining it. It is fast. When we are using a neural network, the response is very fast. What is slow is the training process. And we need to do something for the natural logic, because I was unable to train this network in order to detect, for instance, the negation. It didn't work very well. So at this point, we have several approaches. We have advantages and inconvenience for each approach. And the conclusion was that for our problem, each approach is too limited. So what we did was to try to combine several approaches, and finally we arrived at this solution which combines multiple methods in order to solve the problem better than any of the individual approach. For instance, if we use only the neural network classifier, we'll have too many false positives that we can eliminate if we use also the lexical analyzer and we combine the output from the neural network with the output from the lexical analyzer. Because we do not want to lose the cases where all the words are present, we use the regex matcher also, and the final result may be filtered if you want to avoid that situation with the with the negation. And that's the contradiction filter. And this was the solution that we implemented and that we are using in production, in fact. Now, as conclusions, this domain was quite new for me. I'm not an expert in natural language, but was very interesting as a developer to do some research in this context and to see what it works and what it doesn't work. And a conclusion is, even if a tool is considered very good, you need to test it on your own data in order to see if it's good enough for you and for your problem. And maybe sometimes you should combine several approaches because none of the existing approach is good enough, as in our case. The similarity is a tricky problem because it's even difficult to define what similarity means. In some case, it means one thing, in another situation may have a different meaning. And as future work, and we started to work a little bit on this, it's the automatic topic discovery, which is based on clustering algorithms that should discover what are the main topics inside the list of sentences without defining previously the topics. And here we have some results which are not included in this presentation. We were able to find the words that appear frequently in the call transcriptions, but we still have this problem of sentence-level semantics, meaning that I can detect that some words appear repeatedly, but it's difficult to detect that some ideas appear repeatedly because the sentence level meaning is still difficult to measure. That was all, some references, and I think we have some time for questions. Thank you.
Thank you very much. We have 5 minutes for questions, so don't be shy. Go for it.
Was it a simple neural network or a back-propagated neural network?
Well, it's a classical, what I used is a classical, a backpropagation neural network and the paragraph vector approach. I also evaluated that other kind of network, LSTM, but the results were not so good, or at least the API I found on Python using the Google News database give no such good results for our case. So this is why I prefer to use paragraph to vectors approach.
Thank you very much.
Thank you.
Thank you for your question, and thank you, Marcel. Any other question? Okay, coming.
Hello. I have a question regarding the contradiction filters. What approach did you taken in order to manage that, achieve that? Thank you.
Well, for this kind of filter, I use something very, very basic. First of all, the sentences are splitted, so I will not take several propositions. I only take one sentence, okay. And if we have a match, I count the negation parts, like I may have not, I may have a suffix, prefix that will negate. And I count on the two sentences, and if the count is the same, it matches. If not, it doesn't match. But this is not perfect, because I might have...
Then you won't find many resources. How did you manage to work with this? Thank you.
Well, some of the approaches are not language related, but the most advanced one, they are related to the language.
Amazing keynote. I think he earned a round of applause, so... Next up, I'm going to invite Paul again on the stage. We have another startup pitch, so bear with us. Paul, please.
Hi again. So this next startup promises to make your lives as developers easier. And that's all I'm going to say. I'll let my colleague Cosmin give you the details. I promise you might find something interesting in this one.
Thank you. Hello, my name is Cosmin, and today I want to talk about Mike. Mike is a software developer working at a startup. We all know how cool it is to work for a startup, but there are also problems. Problems because you always have something to change. In Mike's case, he always has to change requests from his project manager that wants to modify, for example, the checkout process and integrate some new features there. And he has to change things from the marketing side and from the sales side and so on. That causes delays. And his project manager wants to be able to make these changes happen faster and in some cases without Mike's intervention. That's where Hashiru comes in. Hashiru is a low-code development platform that is composed of a Hashiru server. You install this in your infrastructure, and it allows you to execute user-defined processes. Something like a user login, a user registration, you can define these through a diagram from our platform, and then you just deploy it in your architecture and you call an API to access it. The server is free and open source, and it allows you to have an extensibility point in your infrastructure. We also have the Hashiru Server Enterprise Edition that allows you to scale the processing side, the server side, to thousands of servers. And we offer enterprise support and business analysis. You can use the Hashiru platform, which allows you to define these processes through an interface, through a diagram. You can speed up your work a lot by reusing some of the processes we defined and processes that you can add, and you can deploy to one or multiple servers. And also you have secure credential management for anything that you use third parties and you have to integrate with. How does it work? You go to hashiru.co, you sign up and you create an application. Within that application you define some processes using a diagram, and you deploy that the entire application on your server. Using this, you can integrate with any third-party service, and you give your project manager, your business analyst, the possibility to modify these processes without your intervention. We're currently in a closed alpha stage, and you can sign up to hashiru.co to get notified when we launch. And you can meet us at the Startup Boulevard to discuss more and have a demo of this. This way you and Mike can work on the things that are really important in your business without focusing on the nitty-gritty changes that come all the time. Thank you. Visit us on hashiru.co. If you have any questions. Okay.
I'm sure people will catch up with you in the breaks or at the after party afterwards. By the way, I hope you will all join us after the event at the Euphoria Beer Garden. Yeah, we're gonna have La Fabbrica de Bere. We're gonna have a party there, so I hope everybody is joining us. Thank you, Cosmin. Good luck, and thank you for the presentation. Next up, we have Cristian Orășanu. Welcome, Cristian. I think we should welcome him with a round of applause. This is a keynote I personally was looking forward to. Cristian will talk about incubator economics, how the rest of the Europe sees us, and about a few success stories of Romanian startups. So looking forward to this one. Good luck.
Thank you. Hey. Hello. Hope everybody can hear me right. I apologize for not having the best voice ever, but I haven't slept in quite a few days, if I may say so, you know how startup life is. Now, before we go on, we will talk today a bit about the European landscape in terms of startups, what we're doing at Crosser in terms of innovations at corporate versus startup and how it usually works, some notable stuff, and a closer look at three really, really cool startups. Now, before we begin, can I ask you how many of you are interested in startups or are part of a startup right now? So we have one. Oh, quite a few people. That's amazing. Now, I'm not the funniest person, but I know that in order to win the crowd when you give a talk, you have to start out with a cool joke. Unfortunately, I'm not the funniest person, so I did whatever young professional would do, and I've asked my colleagues. I asked the startups we have in Innovations, which is an incubator, and asked them, hey, do you have an opening joke I could use for this talk? But the guys, being how they are, they just wished me well. I then turned to my boss, who wasn't that much helpful. And then, in terms of desperation, I reached my mom, and finally my girlfriend. And yes, if you're wondering, we're still out of milk. Now, let's begin the talk. What we have here is a map did by Startup Manifesto, which is a group that looks at each country in the European Union, and they index each territory based on how proficient they are for the startup culture altogether, and the chances a startup has in succeeding if they open in that territory. Now, Romania here seems to be doing well. It's right in the green. It could be doing better, but it's not the worst. And this is a surprising thing, in my opinion. Because the general assumption when you talk to people about Romania and startups in Romania, they act like they never even heard about it. You know, even though we have amazing startups here and we have amazing success stories like Bitdefender, which was a startup at one point. Now, Europeans say that we're doing well in all possible areas, like institutional framework, access to talent, skills and educations were actually considered to be the first. So what's missing? What appears to be missing from Romania right now is access to capital and thought leadership. Basically what these guys are saying, and it's a bit controversial, is that we don't have cojones and we don't have money for startups. But I actually think this is not the case. I think that even if the majority of entrepreneurs in Romania say that they need to be allowed to open a startup, and most of them, more than 70% of them, work for less than 1,000 euros a month, I think that we can actually do better. Here, we have a table from Bloomberg, which is an innovation index. They, again, look at all of the countries, and they give a score to each territory for innovation. What place do you think Romania is on? It might be surprising, but we're 37th in the world. I like to say 37th since we got back here. Now, the solution we're proposing, and the following three slides are courtesy of Robert Knapp, which is the CEO of CyberGhost. He's an entrepreneur who moved to Romania. He opened CyberGhost, and he recently sold it to Crosser to my company for 9.2 million. He initially proposed the idea of Romania Startup as a Service, which is a pretty cool idea in my opinion. Let's whisper of a dream where Romania is the Silicon Valley of Europe, maybe even the world. Right now, we have version 1 of the product. Like most startups, you know that this is usually what version 1 of the product looks like. Version 2, of course, will be much, much better. We just got a new CEO. And the shareholders just found out that they can hold the annual assembly every single day. Look, what I'm saying is this. If this African dude can build a 3D printer for less than $100 out of trash, and the Indians can do a Mars mission for less than what it costs to do a Hollywood movie about a mission in space, I think that we can do this. To be honest, we are doing this. Just look at how we Romanians have to go to market. When US companies want to roll out a project or a startup, they roll out US first. Their market, 324 million people, is good enough, of course. Then they roll their English verbal and they try to go globally, and they get stuck because they find they have copycats all over the world. By the time they cross the ocean, we already have it, and not from them. But let's look at Germany, which is considered to be leader in terms of European startups. You have Rocket Internet there, and they have the copycat model. But not only. Germans, when they roll out a project, they roll out in the DACH region first. 97 million people, again, is good enough of a market. Then they want to go global, and they wonder why nobody speaks German. Then they get stuck. Romanians, we have to go globally from day one. 20 million people is not good enough. Our perks and what we're known for, every young Romanian is a full-fledged technologist, speaks 1,000 languages, and can learn a new technology or a language in less than 2 days. But the truth of the matter is that we innovate. We have to innovate. That's how we win the game. Now, innovation, I know over the past 3 years, I think, it's been passed around like a buzzword. But what is innovation actually? It's bringing out something new or doing something old in a different way. And the reality is that more than 30% of all products sold today globally are not older than 3 years old. So if you want to be alive in 2020 or 2024 or 2026, as I have it in my slide, you have to innovate. You just have to. Now, what I believe is that innovation is achieved when you put a lot of smart people in a room, and then you just let them talk. Let them figure it out. Whatever problem it is, they're going to come up with a solution that's most likely going to be innovative. And Romania caught on. Just look at the landscape we have in terms of the ecosystem for a startup or smart people being in a room with different backgrounds and different technical skills, or maybe not even technical skills, marketing, management, business, whatever. Of course, the leaders in this space is Bucharest and Cluj. And this is where we come in. Crosshair is a company that started back in 2010. It was just 2 guys and a cat in a living room coding away at their laptops. They were doing browser extensions. They were successful. They caught the attention of Teddy Sagi, which is an internet billionaire entrepreneur from Tel Aviv, relocated to London. They got acquired. A few years later, they were listed on London Stock Exchange, and right now, just the public part of the company, which is about 30%, is worth in excess of 70 million. Innovation is a project that stemmed out of Crosshair. It's more or less an incubator meets an accelerator meets an early discovery program, because within innovations, what we want to do is we want to be the mentors. We want to contribute with our skills in terms of marketing, media buying, traffic acquisition, market positioning, and all that. Our technical side as well, because we have we have more than 2,000 developers working for us all over the globe. But we want to come up with the financing as well. So the projects that come into innovations, some of them stand a good chance of receiving financing straight from us. And in terms of budget, we can usually support anything from seed stage all the way to an IPO or a buyout. What we have here is a symbiotic development model in the sense that we try to work with entrepreneurs, the resources we have in the company, the parent organization, the full family of company that we're part of, which is Playtech, which is a $3.5 billion company, and of course the funding side. What we do differently is we have zero equity onboarding. We have a cool mentorship program with mentors outside of the company as well. We provide legal and accounting support at no cost. We have some funding and, of course, the network. This is our roadmap to investment. It's really easy. You just apply, then you participate in the program, participate in the events we have, you pitch your idea at the end of the term to us, and we can decide how to proceed forward. What we're looking for is rather simple. We have a few verticals of preference, if you will. We're looking at ad tech, creative CMS technologies, basically everything that can be released mass market as a B2B digital product or a B2C digital product. These are the projects we're working with right now. In order of appearance, All-In is a really cool casino game. Product Lead invented a new technology that allows you to do shoppable photos. So imagine next time you're reading a newspaper article and you're wondering what, I don't know, an actress is wearing. You can just click on the dress and it's going to send you to an e-commerce with the affiliate link already built into it. So everybody makes money on this end. TapNap is a social media network. Intersect is another social media network. Drinktopia wants to reinvent the way we go to bars. They want to allow you to order drinks straight from your phone, have the drink come over, pay with it cashless, and everything in between. Listed is a cool marketplace for IT, but what they're actually trying to solve is a big data issue. that even Amazon is having, and it comes from working with different suppliers for different products, the way the data is structured. And finally, Cyberfog. Basically, the stats are 2 international teams, 2 founders that were featured this year in Forbes Top 30 Under 30. We have partnerships with Microsoft, universities, a couple of big funds in Central Europe, 1 awesome working space, and of course, the ping pong table. Now we come to the parallel between the roadmap you guys have. Some of you have to choose between starting your own business or working with a startup or going the corporate way. Now, let's have a look at what happens usually, and can I ask how many of you have ever been a corporate employee? So we have a few. So you guys manage the project, you know how it goes. What's the first stage whenever a new corporate project gets launched? Everybody's so enthusiastic, everybody loves it. The project is gonna be a success for sure. Then what happens? Total disillusionment. The project fails. Next step, of course, panic and hysteria. Then we search for the guilty, we punish the innocent, and we reward the non-participant. I'm sorry, but some of you might relate with at least a few of these stages. But startups aren't much better either, because the reality is startups sometimes don't start up. This is a quote I actually like. As a startup CEO, I slept like a baby. I woke up every 2 hours and cried. The DeviantArt co-founder said that every time they launch a new feature, people yell at them. And finally, this is a personal observation, entrepreneurs are the only people who are willing to work 80 hours a week in order to avoid working 40 hours a week. Now, here's some proof that we're doing this. These are some information relating to the market. In 2016 in Romania, we had 20 startups who raised more than 10 million altogether, you know, cumulatively. It's much better than what we had in 2015. These are some notable recent moves. UiPath was just announced, I think, last week that they raised 30 million. CyberGhost, our acquisition of CyberGhost, DCS Plus, which is another really, really cool startup. So things are moving. If you look at the exits alone in 2016, more than $72 million in exit. This is the investor landscape. This is not everything that's happening in Romania right now, but these are the most active players. At the top of the game, we have Jack Adventures, of course, 3TS Capital, Catalyst, and Early Bird Ventures. All of these guys made it all possible. So where we are here in the startup ecosystem and the whole entrepreneurial environment we have in Romania, we pretty much have to owe it to these guys, because they were the ones who committed big money to really good projects who needed it at the right time. Now, let's meet some really cool people. This is the most interesting part and the most fun part of my talk. Meet Cyberfog. This is a team that went through innovations. 2 years ago, they were basically trying to borrow money in order to rent a van to go to Warsaw for an accelerator, for Hubrom. The guy in the middle, I'm not sure where the guy in the middle with the orange t-shirt, that's the CEO, Mihai Raneti, an absolutely amazing genius guy. His story is rather simple. He bootstrapped for 40 years. What he's doing is he's bringing honeypot approach to cybersecurity, and he's building his own processor with machine learning integrated in it. Right now, he's in a really cool step. He's in advanced discussions. He received a term sheet from Tom Draper, who is one of the first investors in Tesla, I think, but also Hitachi from Japan. So they are moving the needle quite well. Next, we have CyberGhost, which is the team we acquired. I'm not sure if I see Robert in this picture. He must be somewhere in the back. He's not the tallest guy ever. But the idea is this. CyberGhost started small. They bootstrapped in Romania all of this time. In 2011, they had 7 employees. In 2017, now they have 55 employees with more to come. We have plans to actually do quite a little bit of hiring with them. They started from basically little to no revenue. They do a VPN service. I'm not sure, are you guys familiar with it, with CyberGhost? No, it's a VPN service for the consumer. It works on Apple, Android, Mac, and Windows. This is Huli, by far one of the coolest teams in Romania. They have mixed founders. This is that Tom on the right here is English. In 2012, he met with Razvan on the left, and together they started the Huli journey. Basically what happened was they had to pivot at least 3 times because what they were doing wasn't working. They initially started with a marketplace for professionals, then they shifted into how do you find people that can help you, and now what they're doing is a social network similar to LinkedIn. So what the way they're selling this is a LinkedIn that actually works, that actually delivers. But the cool thing about them is that they, in 2016, in March I think, they raised 6.5 million from China, UK, and US in just one round, and now they expanded the team. They have an amazing office in the middle of Bucharest, and they are one of the most sought after companies in Bucharest at the moment. They are by far one of the hottest startups. Basically, what these guys are trying to crack right now is people search. Imagine any of you guys at one point in your life, you need something from somebody. Either you need an intro if you work in sales, or you need a job, or you need a designer to do the front end for your app, or whatever the case might be. Of course, we're going to work with the people we have in our networks, but it's sort of hard. We don't know who's available, who can help us, how they can help us. So what they're trying to do is they're trying to build an AI that will tell you who's available, who can help you, who wants to help you, and everything in between, and just connect you to it. You just describe what you want in natural language. I need a front-end developer that's going to cost me less than $200 for this one-time project. And then they just, yeah, there we go. So this is it, guys. Thank you so much.
Working? Working. Thank you. That was a lot of awesome information for me. At least it was great to find out all these things about Romania, and I really appreciate the confidence you have, and I hope we get there someday, like someday soon.
I absolutely think we're there already. Thank you.
I think so too. Don't run so quickly.
Okay.
Are there any questions? Yeah, there are.
We have questions?
There you go.
Hey, and thank you from me as well for the wonderful talk. One question, did you have any startup that didn't have a salesperson? So to start just purely technical, and how did they manage to succeed or not?
Well, to be honest, besides the technology that allows you to pin items in a picture and turn them into shoppable links, besides them, not a single one of the companies we work with right now have salesperson. They don't have salespeople. Most of the sales are automated through media buying, through organic search, if you will. They're working really hard with PR, getting the word out, and they're hoping that that's how the right people will come to use their solutions, regardless of if it's business to business or business to consumer. So sales in startups, it's usually the fifth hire. Usually the first hires are technical. After technical comes front-end graphical, right? And after graphics comes sales and business people all together. That's how it goes. Do you have any other questions?
Any questions?
No. Okay. Thank you, guys.
Thank you. Okay, so we're unusually on schedule, so we're still waiting for Silvio to arrive. Meanwhile, I would like to thank Christian again for the wonderful keynote, and I would like, meanwhile, if you have these 5 minutes, to remind you about the after party that we're having after the event at Fabrica de Bere. And I would like to remind you about the sugar wall we have, and to encourage you to leave messages for your favorite speakers. Tell them how much you love their keynotes and anything else that you have in mind. Please have a little bit of patience. Okay, we have 5 minutes, 10 minutes to spare. 10 minutes, they're telling me 10 minutes. So we have 10 minutes to spare. Have a little patience, and see you back soon with Silvio. Thank you.
Super. Bun, bun, bun.
Okay, so we're waiting for people to come back, but meanwhile we're going to slowly start. I'm going to introduce you our next keynote speaker. You already know him. He's basically like in all the talks, like there's a talk and then he's back and all that. So once again, Silviu Șerban, thank you for coming. He's going to have a keynote about AI and how AI is changing the world, and IoT, of course. And in his presentation, there's going to be a short kind of pitch for Helios Vision, the startup Silviu is developing. Therefore, come in, don't be shy, come in. I'll leave you to it, and good luck.
Oh, thank you. So, hi everyone. We've met this morning, I guess, at least most of you. I'm going to talk to you about changing the world with AI and IoT. First, we're going to go a little bit into AI and some features of it, and IoT, and on the hardware part mostly. And then we're going to talk about how we are using these technologies in our projects at Helios. So let's begin. So artificial intelligence. I guess, how many of you know about it? Everyone, I'm expecting everyone to know about it. At least to have heard it. How many of you develop in the AI field? So yeah, much fewer. All right, so AI is a branch of computer science. I know when you hear AI, you think about, I don't know, the Terminator or RoboCop or something, but it's just computer science. It's a computer science with intelligence. So one main thing about AI, or one important branch of AI, is the ability to understand what people are saying and to try to answer their queries. So we have conversation. One, speech to text. So we want that anything that we say, we want it to be translated into something that a computer might understand. For that, there's a lot of algorithms behind who try to understand your language, your specific accent, your specific intents, and then translate it into a language that the computers might understand. The reverse is speech, it's text-to-speech, which means you have a text which might be written by humans, or it might be a response from an AI or a robot, which is transformed back to spoken language. This has been done, I don't know, classically. You hear it in GPS, in your, I don't know, Google Drive thingy. You hear some recorded voices of people for specific topics. Nowadays, I don't know if you're familiar with what Google is doing in this domain, but they're going to be able to generate speech with specific voices, which will sound almost natural in the following years. So there's a lot of advances into this particular area. Okay, so language understanding. This is the process beginning at speech recognition, then growing to natural language understanding, and when the AI understands your intent, it will hopefully fulfill your intent. So you ask your robot to fetch you something, and the robot will bring it back, or your AI. Imagine it, when I say robot, I don't mean specifically physical robot, but also a virtual one would do the same. So how to enable conversation in your AI? Well, you can train it yourself. I think this is the long route, the most fruitful route, the most interesting route. And right now, the state of the art for this is deep learning. I don't know, how many of you do deep learning? Yes. Nobody does deep learning? No. Have any of you used TensorFlow? Okay, so you have TensorFlow. So maybe you did some deep learning and you don't know about it. Oh, just in college. Okay, so this is the, let's say, the long route, but the most interesting one. This is how you find out how things work and how to program them yourself. There's an easier route, which means using cloud services from people who built some kind of AI structures. So you have Amazon Alexa, which is the most popular at the moment. You have IBM Watson, which is also very cool, but not as used for some reason. And you have the upcoming Microsoft Cognitive Services. These are all really interesting, and there's many other AI startups that are doing services in this domain, but I guess these are the most used ones at the moment. So if you're like a beginner in AI and you want to implement some, let's say, more than intelligence in your software, this is one way to go. All right. So now, second one is vision. This is the one I like the most. This is what I've done for the past 8 or 9 years. And by vision, I mean understanding the surrounding environment using cameras or other types of sensors. So when I say vision, I mean computer vision. I mean object detection, tracking, and recognition. More than that, we have identification, understanding emotion of people who are in front of us, and all of these technologies can be implemented in an AI and from then on into a robot. For vision, we also have SLAM. Who knows about SLAM? People should know about SLAM. Simultaneous localization and mapping. This technology was first used for the Mars rover by NASA, and it's something like this. Let me see if I have a video for this. So you basically have a robot or a car or some device or a person who's walking around and collecting data. And what SLAM does is create and map in real time that specific environment. It's extremely cool, and it allows robots and even self-driving cars, at least some of them use SLAM, to navigate on their own and to continuously learn and improve their mapping. All right. So, okay, this is it. Okay, now a quick switch to IoT. This is just something about hardware. So IoT is the ever-growing network of smart devices around us. I mean smart, the fact that they can communicate with other devices, and as a whole, they can tell us a lot about what is happening in the world around us. So first, smart equals processing. Which of you has used an Arduino by now? Okay, so many of you used Arduinos. This is much more popular. So I think this is the smallest, or one of the smallest pieces of hardware you can use for an IoT project. This is where you begin. You can make a small robot that follows lines, that just moves around, and maybe you can remote control it. You can play with it. Well, let's say you want a bit more. Let's say you want this controller to have, let's say, some more intelligence, like a CPU, a real CPU, and a connection to the internet, and maybe has a camera attached to it. So from your small IoT robot or project or whatever you're doing, you can just go a step higher and improve this just by using a more powerful board. Now, I'm showing these boards because I'm using them in a project I'm building, which I'll show just a little bit later. This is like the most powerful IoT board I have used. I think it's the most powerful consumer IoT board on the market. This is basically a full computer at this size. So I'm using this in my project to run ROS. You know ROS? ROS is the robot operating system. It's a really, really cool open source project which allows you to bootstrap, in the case you want to develop a robot, it allows you to bootstrap your development time, I guess, by a really, really decisive factor. So, we go to the next part, which is sensing. I mean, IoT is nothing without sensors. I think when I think about IoT, I think about the ability to capture the information around us. So we cannot do that without sensors. So you can have real-time monitoring. You can see the CO2 levels or the dust levels in a room. You can see how, okay, we could actually know how many lumens are in this room, or the temperature, or the humidity, etc. And we can use sensors for automation. This is mostly used in industry, and it has been used for, I think, tens of years, yeah, many, many years. It's just getting to the, let's say, to the public, or more available to the public recently, as many companies develop this kind of maker tech, or maker boards, maker sensors, to allow people like you and me to create prototypes that can then become products in the market. So, again, sensors can be used for prevention. They can extract patterns. We can send a lot of data into the cloud and then learn that something is bad and try to prevent it before something catastrophic happens. And that's anomaly detection. All right. So now we're going to head into what we're doing at Helios. So, first, I'm going to talk to you about Astro. I'm going to just talk a little bit about Astro because Astro is in development right now, and it's semi-shy. Astro is an intelligent robot. It's designed to improve productivity and safety in the office space. This is how Astro looks like right now. This is the first prototype. It can, let's say, not replace a colleague, but help with things that are really, let's say, programmable, like querying information or learning about the environment in the office. Like Astro has a bunch of sensors to do that, to let you know that there's something wrong in the office. You should maybe go out or crack a window. And it can also move on its own. It has 3D SLAM technology to move around and learn its environment. And the face you see there, it's a full-blown AI, which can take queries, talk to you, and of course, be your pal if you're into that. Yeah, that's it about Astro. Okay, this is how Astro would look like, or will look like in the future. This is our 3D projection of the robot as a product. Now it's a POC mostly. So if you want to ask me more about it, I'm available after the presentation. Also, if you come to DevTalks Bucharest, I might have Astro there for a chat. So for those who come there, see you there. Okay, next it's Helios. This is a project we've been working on for a longer time. Helios, it's addressing a worldwide problem that maybe it's not that known, but it's actually a really big problem, which is people with severe vision impairment. So as you see, the problem size is quite big. There's like literally hundreds of millions of people with severe eye problems that cannot be fixed by using lenses or other surgical procedures, etc. So, what do we do with Helios? Firstly, we use computer vision to enhance what people with low vision can see. So maybe they cannot really understand the world really well on their own, but using our headgear, they can see at least the nearby world and know that there's a person in front of them, there's a desk, there's a chair, and which might not seem like a lot, but for someone who does not have that information to begin with, it's actually gold. We have a cognitive AI embedded into our technology, which allows people to learn others, to learn their faces, to recognize them, to understand their emotions, things that are completely new to a lot of people who can maybe feel emotions by sound to understand that you're laughing, but have never seen a smile in their life. So for this, we have the cognitive AI, which can help or at least bridge a little gap from understanding these things to not having them at all. And thirdly, we have a remote caretaker, which is, imagine Skype, but for people with visual impairment. It's like an instant Skype. You just press a button, and you get, if a friend is available, you get connected to it, and he can be your eyes. Just like that. It works anywhere where you have internet, so it's quite, let's say, 4G dependent. But apart from that, it should work in many urban areas. Okay, so here are some benefits. So the biggest benefit of using a technology like this would be the freedom of movement. For people who have low vision, they usually just see a little bit. So they still need like a walking stick or a dog or a friend to walk with them at all times. So they're kind of confined in their day-to-day lives to depend on other people. So with this, they would depend less on other people. They would actually be able to see at night because we're using infrared sensors to capture that information during the evening. And let's just say it's empowering. Maybe that's why it's the most important of all. Secondly, it's the workplace performance. I mean, people with vision disabilities, some of them do work. They are integrated in society, and they can do things up to a degree. But using Helios, they could actually do it easier and faster. They can actually extend their area of possibilities. Now, it helps a lot with learning because we do have OCR and text-to-speech embedded into the cognitive AI, so they don't need to be restricted to Braille. They can just use regular books, and the AI will read it to them. So it'll be like audiobooks, but real-time with real books. And the fourth, but I guess not the least, is social integration. I mean, the ability, as I was saying before, the ability to understand more about the people you are around and to maybe get to recognize them as this is something like normal for me or you to see a friend, I don't know, 10 meters away and recognize him. And this is something that people with low vision do not have and will benefit greatly for it. Okay, so this is a photo of Helios at some conference. I presented it. And this is how the headgear looks, actually. It does need a computer to run, but it uses VR and 3D sensing and a lot of software to allow people to do the things I just said. I mean, I could explain this to you more, but I have a video about with one of our collaborators who is legally blind, actually testing and using the device in an area he would not be able to navigate normally. All right.
I can see clearly now, the rain is gone. I can see all obstacles in my way. Gone are the dark clouds that had me down. It's gonna be a bright sunshine day. It's gonna be a bright
Good, that's it. Okay. So, thank you. I would have questions.
Yeah, it's time for questions now. Okay.
Hi.
No, okay.
What kind of feedback do you present to the person that's using it? Just enhanced visual or haptic or audio also?
Enhanced visual and audio for this prototype. We do have another prototype which also provides haptic feedback. That one we may open source this year, so follow us if you're interested to do some projects in this area. Now we're focusing on the, let's say, bigger part of people with vision impairment. As you said, you saw in the video, there's over 285 million people with severe vision problems. Out of these, I think the maybe 80% have low vision, and the rest of them are completely blind. So we are addressing both, but with this demo and this prototype, we are addressing the ones that can still see a little bit.
Okay. Another question.
Sure.
Have you ever thought about switching to the HoloLens? It's more portable and it already has an environment mapping dedicated hardware processor. I think it would benefit greatly.
No, HoloLens is awesome. Without a doubt, it's awesome. The only downside with HoloLens is that it is augmented reality. So basically, with HoloLens, you get an overlay, right?
Not just that, you also have audio and haptic integrated directly into the headset.
Yes, but I mean for this specific case, having something drawn in front of your eye, which already doesn't see much and doesn't understand much, is not really a gain.
Yeah.
So that's why we're using VR. So we're making everything pitch black, and we're giving or focusing everything on that tiny bit of light their eyes can perceive, and trying to offer that in the best possible way. So we're gonna switch not to HoloLens, but to an all-in-one VR headset. Yes.
Mixed reality.
I cannot say the name yet, but it will be coming shortly.
Okay.
Thank you. Yeah, any other questions? Oh, we have a question there. Oh.
Do you use SLAM to help, in this case, collect to navigate?
SLAM for, you mean for the Helios project?
Yeah.
No, it doesn't really require SLAM. I mean, you use SLAM for an autonomous machine, right? Like a robot or a car.
Okay, so on that particular project, you do not use any SLAM?
No. The SLAM is for the robot. The robot does use SLAM and likes it and needs it actually to not bump into everything. But for this one, it's let's say real time. SLAM needs time to learn and then to generate the model, which maybe if you're like a person who doesn't really see well and you're wearing this and you're going to a new area, learning it will not really help you then, maybe it'll help you afterwards, but things are really mobile in the world, you know? At some point this monitor will be here, maybe later it won't be here, so it's, you need to have everything real time, as much information real time as possible, and usually focusing on the critical one. Like, is there something in front of me? Am I gonna step into some disaster? So we're focusing on that, on the now. So with SLAM, you learn and you reinforce the learning. But no, in Helios, we did not see the need for it. But we could, I guess, if we really wanted.
Okay, well, next question. Also related to navigation. Do you use any stereo techniques to determine the depth of the distance to object, or?
We're using the 3D camera with lasers, so we don't need stereo vision for it. On another camera that we have, it has two laser sensors. So for that one, you could use stereo vision on the depth image. So that helps. You can then know exactly the size of things and the exact distance to the thing. But even with one IR sensor, you still get a pretty accurate estimation of the distance to an object.
Any other questions?
Questions?
Did you consider to go one step further in order to help other people, not only the ones which are partially blind, and help the people which are legally blind, for example, people who have optical nerves which are not working at the moment, to perform any cortex stimulation or something like that?
Well, I think it depends a lot on the damage, right?
Yeah.
So some things can be solved surgically. I think there's a lot of medical procedures that involve brain implants at the moment. You can actually do that in many cases, maybe not many cases, in some cases. Yeah. Hopefully the future will bring us better solutions for communicating with our brain, especially when you said you don't have anything. Yeah. Then it's difficult. I mean, you could have haptic feedback, which we do implement in another prototype, and you can have sound. So maybe this is the only two non-intrusive ways of providing the information. Yeah, the rest would be intrusive. You would have to plant a chip in someone's brain, which is maybe not the easiest problem. Yeah. I think the brain learns. There's usually learning curves, right? You present new information to a brain, and the brain will adapt. That's the magic of being us, right? We adapt. So even someone who's not really used to some kind of new information, they would learn after a while. Now, there's always learning curves. Some are really steep, some are really easy to climb. But I think even with the new information, they would learn. If they put their mind to it and they want to use that information, they will get there. Yes?
Hi. Helping people with visual impairments has been one of the things that fascinate me the most. And my question for Helios is that people with complete blindness usually walk around their rooms with lights closed. So how would Helios help when there is no light around for blind people?
Oh, but that's the case with the IR, right? Infrared means you don't need light. You can see at night, it doesn't matter. So this actually helps even people who cannot see at night. So there's some people who can get a degree of light during the day, and when you have the evening, they become blind. So wearing this would allow them to get the information in the evening also, because that's IR, right? You can see basically any time using.
That answers my question. Thank you.
Awesome.
Who's next? We have time for both of them, so.
Hello. I would like to ask you, why do you use infrared energy when you could use ultrasounds? It could be dangerous for the brain.
Can you repeat that, please?
Why don't you use ultrasounds, which would consist in the same way for the mapping area instead of infrarays? Because it could be dangerous for the brain, because there's the level, the SRC, that could elevate the temperature of the brain, which could be dangerous.
Oh, you mean is this dangerous for the user?
No, I'm just asking you.
No, this is perfectly safe. It's a class 1 laser, which means its output is far below what would be called dangerous.
Okay.
And secondly, IR in this case, and at this, let's say, form factor, does provide better results than using ultrasound.
But for example, if I have a radiator turned on in the room, do you think it could
Like, it will shine brighter, yes.
It will
If
shine
there's a
brighter, yeah.
radiator, it will shine brighter, but that's about it. And we do a lot of image processing or computer vision from the input to what the user sees, so that doesn't really affect the output as much. So for the user, it will be a little bit brighter. So yeah,
Okay.
if you have like a fireplace,
Yes.
yes, it will be very, very visible.
Yeah, so that way I would suggest you to use like ultrasound because it's much safer. Because like I'm a medicine student, and for when we have to like some radiologies or stuff like this to the brain of a baby or to a human being, we use US instead of.
We are using ultrasounds for the robot.
Okay. Yeah. Okay, perfect. Thank you very much.
Thank you. Thank you so much.
What's the autonomy of your product, and what's the how usable it is? I'm meaning how much it weighs.
Now, you have to carry it in a backpack because we do need some processing to do everything. In the near future, we'll be having this as an all-in-one wearable. So we can actually shift to that pretty soon, hopefully very soon. But for the moment, for trial and testing it with people with visual impairment, this is good enough. I mean, they don't mind waiting like 5 minutes to get dressed. The autonomy is based on the battery, so maybe 2 hours, depends how well charged the laptop is or the tablet we're using. But if you're using it at its peak performance, the battery will dry up sooner. So I'd say up to 2 hours for a charge.
Sorry.
I mean, so you can just send the data and process it on your server and send back the response?
You mean you could service some of the data. So for example, I'm doing a real-time emotion recognition, right? Yeah. This is real-time, but maybe you don't really have to do it real-time. You can offload some of the things. I mean, you could take a photo, upload it to what's on Microsoft or whatnot, and they could tell you what they think about it. So you could have that, but imagine if you don't have the internet, right? And you would still want to have this kind of feature, so you would like to have the option to do things locally. So yeah, you could offload, but still the computer vision intensive parts would still need to be real time. So you do need at least a fair amount of processing to do it. Maybe you cannot do it on a Raspberry Pi, but you can do it on something a bit stronger, yeah.
It was in the sense that you might lose some weight on the device, so it would be more like carryable if you can send some processing or somewhere else.
You could, and actually we are doing something in the cloud. I was telling you about the caretaker feature, which happens in the cloud. I mean, it's a web-hosted application for visual and audio. So that one does happen there, and it's somehow offloaded. But for this, there's just a couple of things that you could actually have not in real time, and you could wait for it. But the rest you do need right now. I mean, at the moment you're speaking, you want it now. So that's a challenge, actually, yeah.
Thank you.
Welcome. All right.
Okay.
Happy people.
Thank you for the great questions. I'm really happy to see that.
Thank you so much, and see you at the panel coming next.
Yeah, see you soon.
Yeah.
Don't go too far.
Should I drop this?
No, don't do that. Yep. Up next, we're going to have a short startup pitch, and then Silvio is coming back because we have another panel with the same speakers we had this morning. So stay tuned. Meanwhile, I invite Paul back to the stage to present the next startup.
Thank you. So again, us developers spend a lot of time sitting down, right? And some chairs are more comfortable than others. So this next startup might help with the way we sit to improve or to get rid of our back pain. So let's hear it from Ionuț and see what they can do for all of us.
Hello? Is anyone here who doesn't understand English? Okay. So first, I must say that I'm Ionuț from Team 4 People, a team that just won the latest hackathon in Cluj-Napoca called Polyhack on the embedded section. More than that, we are 4 students at the automation section, second year, and we are IoT enthusiasts. So more on this. Okay. First, our product is called Officers, because nowadays, one of the biggest problems in offices is back pain. Okay, in our perspective, back pains in offices should be prevented and not treated. More than that, for example, a use case. A programmer is most efficient for their firm after he works, for example, 5 or 10 years, after he gains some experience, and after he is really valuable for that firm. Well, at that age, he can no longer code because he has back pains. And in all big firms, for example, after 5 years of back pains, nobody can sit and write code for 8 hours, or at least efficiently. More than that, what we are doing and how it is used. Our chair encapsulates 3 sensors that works on the capacitance principle, because we all have capacitance in our body. On that, if you don't sit in the correct position, it gives you a pop-up on your desktop, as you're not sitting in the correct position. More than that, if you sit too long on the chair, it will give you another pop-up that states you should get up and maybe walk for 5 minutes because you're sitting for too long. More than that, our technology encapsulates the all 3 branches of text. First of all, the embedded section, because we have sensors and we have microcontrollers. More than that, the desktop, because you're working on a desktop at an office, and the pop-ups should come to your desktop, so it will be full sight, not on your mobile, because you should not be focused on your mobile at your office. More than that, in the future, it will have a mobile application, an iHealth application, that will give you a back profile, and where do you have problems in your back, and how they should be treated, or at least some suggestions. Okay. All in all, I believe all of you here have sat for at least 5, 4, 8, or maybe more hours in a place and felt back pain because you're not sitting correctly. I don't say that this is comfortable at first sight, but when you will be valuable after 4, 5, or 10 years of working, your back should be valuable as well, because at 30 years old, I believe you should be able to use your back at full capacity. Thank you. If you are interested, we have a prototype that works in the Startups Alley at the 1st floor. If you want to test the chair, it works on every person, it is calibrated and so on. So please come test it, see it, and maybe have a chat with us. Maybe you're interested in your back. Thank you.
Thank you, Ionuț. Thank you. If anybody has any questions, they can catch it tonight at the party, or if not, outside in their short breaks. We have another panel now. I'm going to welcome Silviu back on the stage. We've missed you, Silviu. Long time no see. This panel is actually an open talk about IoT, so get your questions ready. We would like it to be as interactive as possible. The speakers that I'm going to welcome for this panel are the ones that you saw this morning. We have Andrei Crăciun, come on stage. We have Anatol, and we have Marcel, which I don't think, yeah, he's over there. He's coming soon. So please be seated, guys. You would like a chair? Of course, sure. Can we help him with a chair, please?
And maybe move it there, yeah.
It's called adapting. Could you please tell us a few words, just a short description of the panel, and I'll leave you to it.
So, does it work? So we're going to talk a little bit about IoT. And it's an open discussion, so we would love to have you guys join with questions at any time. We're going to have some topics and relate some of our gain know-how from developing IoT projects. So, I'm going to start with a question, and people are going to answer. So, what does IoT mean for you when you think about IoT?
Well, other things than Internet of Things. Or
yeah, well,
it's IoT is what we used to call 10 years ago home automation, and it's I'd say, and a lot of people say, it's just a fancy name for everything that requires embedded technologies and everything that requires to connect our software and our tools to the real world.
You guys?
For me, IoT means two things. One is the fact that we have a lot of new opportunity to create applications. For instance, to have highly distributed systems in order to acquire data from sensors, have actuators, be able to remotely control things. But another aspect is, I think, a high vulnerability if a hacker will enter in such a system and will control such devices. And I think it may be even worse than for regular computers. So the security aspect is very important.
I'll take it from here. As my friends used to say, the S in IoT stands for security. So you can understand how the terrible security in IoT is. For me personally, IoT means that there's a lot of work and a huge area of attack that we should improve. Because we hear that from day to day we hear news that someone thought it's a good idea to put internet on something. And that's not always the best idea. So for me it means a lot of work and a lot of worries and care when dealing with IoT.
All right, so now that we've covered this, regarding projects you've implemented in IoT, can you share some of your experience and let's say challenges you've had?
Okay, so by the way, who attended my 11:45 talk? Okay, so I'll just share share some things. Usually my biggest problems are with the users, and I had two types of users until now that created problems. By users, I mean, two things. Sometimes it's just the human that benefits of that system, or if other living entity is checked or what happened, monitored. So as a users, my most difficult to satisfy user is my mother-in-law. I developed for her some irrigation systems, and those need to work perfectly. And also I have some pets, thousands of them. They are bees. I do all kind of hardware that try to monitor them, and they keep putting wax on my sensors and do all kind of things so that they're sabotaging my system. So basically, this happens with IoT projects. The challenges are different, and they are very different from the prototyping phase to the product phase or to the field phase, how I like to call it.
Okay.
Well, even if my recent work is not related to IoT, some years ago I was involved in some research projects concerning middlewares for ubiquitous computing. And I work with some devices controlled by different kind of sensors, and the problem was to write rules in order to decide how actuators will change their state according to some input from sensors. I think IoT, it's also, or maybe also strongly related with machine learning, because in order to collect data, we need a lot of sensors, and obviously with IoT, we can do much more things than with regular computer and computer networks. So it's clear a big opportunity for new services. Well, we still have this problem of security, as I said before. This is why we need to be very, very careful with such devices. For instance, I do not want to have my devices from home controlled by another person.
Unless you allow.
Yeah, unless you allow it. So this is a big issue, I think.
My personal experience with IT was that I was in a project, a member of the team that was working on a project that basically had to do this. We had multiple components, and we had, there's this concept that sous vide cooking, and what we had to do is implement a system that will monitor the temperature in the food. The sous vide cooking actually is, basically the process is like this. You take the meat, you put it in a bag, you get the air out of it, and then you have a bath of water, and you put the bag with the meat in the water. Afterwards, you have to keep it at 60, 70 degrees, depending on the type of meat that you are cooking, between 3 hours or a couple of days, like 24 hours, 48 hours, 2 days, something like that. And it's really important to keep it long enough time in order to kill all the bacteria, because it's a temperature at which the bacteria can suddenly develop, and it may be fatal. So there are some formulas that you have to apply and monitor the temperature that you'll make sure that all the bacteria is killed until it's a full kill. So this project was using, first of all, an Arduino with 2 sensors. It was in the kitchen, so we couldn't put a computer or laptop and just connect something via USB or something like that. So we're putting small Arduinos that were fully sealed and had Bluetooth. They were controlling the temperature, actually probing the temperature. Afterwards, near the kitchen, in the next room, we had a Raspberry Pi that would connect to the Bluetooth and send all the data to the cloud. Afterwards, you could use an iPad or an iOS or an iPhone and open the application, log in, and you will see all your sensors, and you would see that this sensor is here for 3 hours, this is working for already 24 hours, and it will show you that in this one, there's a full kill, you can now take out the meat. And the application would log all the data, and afterwards you could sign that this is indeed safe to eat. Fortunately, the security part was easy because this was implemented in a facility that had a closed network, really strict by firewalls and all of that. So, and it was used by cooks. So everything was kind of fine from the security point of view. But if we mention what Marshall said, that you wouldn't want someone to control a device that you have at home, I'll bring an example about a smart device that that is a door lock, a smart door lock. So you would have this door lock on at your home, on your door, from the inside, of course, and you would connect to it using Bluetooth. And you could share the key and allow someone to open. For example, I want him at 3 p.m. To come to my home to get something, but I'm not home at that time. So he has the app, I have the app, I share him my key, and he's allowed to enter, get something, get out, and close it. This door lock was analyzed by a security expert and was presented at DEF CON, and it had terrible, terrible security. Like the security researcher was able to control all the locks of that company. Even though the security model was initially thought in depth, but some parts in the implementation lagged and had some issues. So this allowed him to just control anything, and the device wouldn't even send logs to the server that someone opened the door.
All right.
Just one thing, I'd move things a little further, what happens with the data collected? There is a big issue with this, because some people want to keep their data on their own premises, on their own physical property, because that data may be way more intrusive than we saw it happens with personal social data published on social media. That's one thing. And another thing is, we hear, I don't know, last 3-4 years, or maybe less, we hear about the smart city concept. Smart city is all the authorities in cities want to implement all kinds of functionalities, starting from intelligent lighting to bus monitoring, things like this. And one issue they are facing is the provider. Because usually these projects cannot be done at once, they'll be done in stages, and since interconnection between systems, between big players in industry is pretty hard, there is the risk of choosing one provider, one big company for the very first one, and then maybe at a cheaper price, but then be locked as a customer for that company. And for this, in Europe, I don't know, the European Union, but I don't know, the European Commission or some authority have established a general protocol, and they're working on it. You can check for fireware. There are some servers. They offer tools for developers in order to provide the tools for smart cities around Europe. Basically, the provider should connect to that system and not to have their own proprietary system.
All right, I have a question for the public. How many of you do implement IoT projects at this moment? How many of you used IoT gateways for security? No? No one? So I'm asking you this because it's something newish. I'm actually using it for the robot project, because we do allow for remote control of the robot, which has to be secure, or as secure as possible. So what we did use is an IoT gateway, which is another piece of hardware, which facilitates the secure communication between the robot and the cloud. So we send encrypted information to the IoT gateway, which on its own connects to Azure or AVS, also very secure. And this is one way of keeping your data safe. Now, the way you will implement security on your cloud app, that's another issue. But from your IoT device, depending on how advanced is it, to the cloud, this is one way to make sure all the data gets there without, let's say, any friends in the middle. Okay, so questions? Do you have any questions regarding to, let's say, the problems we've discussed up till now.
What are your thoughts? So there was not a threat, but a concern raised worldwide about the IoT and security threats that smart devices like the refrigerator, all the electrocasting appliances that we use can bring. What are your thoughts on that? Should we have worldwide standards? Should we force manufacturers to use certain standards in order to avoid, for example, denial of service or any other?
I'd like to answer this one. It's actually a pretty hot topic because last year, maybe you've heard of the Mirai botnet. How many of you heard of it? Mirai? Okay, so it was a huge botnet built on IoT devices, and most of them I think were routers, if I'm not wrong, but there were thousands, if not millions, of devices infected, and all of them took over using just the default username and the password. So the number one rule that I would enforce is once you connect your appliance, it shouldn't work until you change your password. This would be my my first rule that everyone should follow in the industry. Because afterwards, what happened? They took over all the devices. They found more vulnerabilities and exploited them because they were authenticated on the system, and they installed their backdoor and started attacking all the sites. They knocked out half of the internet back in September, October. You remember when they attacked the DNS service? So it was a major outage. So number one is just make sure your password is not default one. If you can turn off the remote management, do that.
Well, I think the lesson here is don't buy a smart TV if you don't understand how it works. Or you don't have a good router or any decent type of security for your home network. Because it can be hacked. Someone will learn how to hack it. They don't really update much. So, yeah, the best way to keep safe is to know what you're buying. And this is a difficult problem for, let's say, people who don't have any technical expertise, as they tend to buy a product and expect it to work perfectly from day one without them doing anything. And yes, this is a really difficult problem to solve from a producer.
So probably that's the solution, to make tools and software and that is ready to work ready to be used by anybody. And I'm pretty sure this is the way to go. Probably big companies that provide home appliances, as you said, will gonna get sued until it's not gonna worth them not to build strong systems. And yes, there'll be security protocols, best practices, and so on. And I think those will be applied by the big producers in a faster approach than it was for the standard internet security as I saw it. It won't take 10 years. It will take just a few years probably.
There's a saying that I would like to show you. It says security is not there if it's not by default. So if the password is not random by default and it's just admin, there's no security in that. And recently I've installed a new router for my mother, and the username and the password was random and it was written on the back of the box. So by seeing that, I know that some botnet wouldn't take over my mother's router. That's an example of security by default.
Now I have an open question. Maybe anyone can answer, you guys also. Do you believe that smart everything is the right way for the future? By everything, I mean everything. Any device, everything smart, connected, full of sensors, controlled from afar. Smart everything.
I'm not sure that's the answer, but as it looks, we are moving to that direction. So either we want it or not, that's where things go to. And there is no, up to this point, there is no, cons against this. So as I said also in the morning, probably there will be a moment in time when we'll either just see this as second nature, technology controlling our environment, or we'll just totally reject it. But it's closer and closer to, from my point of view and from what I see, the point where we'll just consider it second nature. I see it on my kids, and the new generation sees this as just the default thing. So we're moving to that direction.
It certainly does help. For example, from experience working on hardware and software product, you do get to collect important data that you otherwise wouldn't get.
Here you go.
Thank you. It does help. For example, on NAS devices, there might be certain technical limitations. For example, user is in a humid area. You haven't got the chance to test on that part. You can get live telemetry and update the boards because they are overheating, or there are all kind of other important things like in RF. They are using in a heavily shielded area or where there are many Wi-Fi networks, and they are influencing your device. The telemetry certainly does help in that case.
You guys have anything to add? Yeah.
I want to add something. Since such devices may help us to create new services, I think they will spread, but we should add security and privacy because obviously more connected we are, less privacy we have. So we also need to think about this aspect, how to ensure privacy for the users that need it, that requires it.
I don't think smart everything is a requirement, but I think the rule of thumb when deciding whether something needs to be smart or not is whether does this solve a problem. If it does indeed, then there's need for this. If it's not, then it's useless. And that may be different from person to person. It's something that everyone should think for himself, like, do I need a smartwatch? Yes or no? Do I need the headset? Yes or no? For someone it is needed, for example, for the vision impaired people, but for some this is just useless. So that's my opinion on this.
Well, the rest of the guys can get Google Glass, and they can see some, well, whatever Google Glass will be when it's done, maybe next couple of months, years. Do you have any questions? Because this is the questions we've had and the topics we plan to discuss on, and we're hoping for you to ask things that you might have, let's say, encountered as challenges in your work in IoT, and we might have some feedback for that. Sure.
What are your thoughts about the GD?
Go ahead.
The streaming is live, and if you don't use a mic, people can't hear you, so that's fine. Thank you.
What are your thoughts about GDPR, the Global Data Privacy Regulation that is imposing by the EU from May 18th next year? How this will influence the whole privacy in IoT?
As I see it, it's probably another, there are good guidelines. For sure, it will bring benefits. Still, as Ayatol said, my fear is that this is going to be the default security. And when we have defaults, then attacks are based on those defaults. So that's the biggest risk there. Yeah, it should be just to, it should not be enforced to this is how security should be or privacy. It shouldn't, what should not happen.
Okay, thank you.
I'd like to add on this one. I haven't heard of this act, but I usually see that there's a lot of movement towards more privacy for the end user in the European Union. And this is just, I'm really glad that I'm in Europe, and compared to the USA, where you may have heard recently that ISPs can sell the data of the users, and that's just insane. I'm glad that where we live here in Europe, there are some initiatives to protect the user. I'm really glad about that.
Any other questions?
Or maybe other opinions? Other opinions about this in the public?
So everything in IoT is good. Yeah, please ask us.
No, I'm really curious if the IoT segment will monetize in marketing data, like for data analysis, and if you think that in the next years there will be like, there is Google Analytics, like Google IoT Analytics, something like this.
That's a good question. Actually, I've worked towards a project in this area. It was for indoor localization and also using, you know, Estimote?
No.
They're like smart beacons. So you could actually have an app running on your phone which will constantly look for those beacons and then send some information to the server. And for example, you're entering some space in IKEA and you're standing there for a while, and then the people in IKEA will know you're interested in getting, let's say, a couch or something, and they could actually send you offers or what they expect you are looking for. So you can definitely make a marketing play using IoT data, especially in malls or this kind of big shops where it matters where people tend to spend most of their time at, to optimize sales and learn from their patterns.
Okay, thank you.
You meant selling that data or just using data to sell other things?
Both of them. Selling data for marketing agencies and using data for selling other products.
Okay, so selling that data is a huge market and they are big players. It's something I've heard about why Google is investing in a self-driving car. So the costs of transportation is the third cost of each family. First it's food, a house, and then it's transportation. So, and people have to travel. You cannot make time shorter. That's it. You can I don't know, increase speed, and actually all those money goes to car manufacturing industry. So these guys want to build autonomous cars just for people to stay while they travel to have more money and to buy other services. So, and this data is acquired at such a level that Verizon, this was 1 year ago or 1.5 years ago, could have predicted in some street how many ladies between 30 and 35 years will pass through that highway between 4 and 5 p.m. and with a pretty good accuracy, so they could sell commercials to them. And this data is taken from cars, from phones, from everything, and sensors and everything, what means IoT is a big hit. And there are companies making a lot of money on this.
Thank you very much.
Awesome.
If I may add something.
Yeah, sure.
I also have let's say a fear, a worry about the fact that when some institution has a lot of data about me, but I do not know so much about that institution, I think there is a danger of manipulation. Marketing is one aspect, but what if politicians will use data in order to manipulate the people? It's a possible situation, and in the future we need to think about this and maybe avoid such a thing. But I'm not sure if it's possible, because this asymmetry between what I know about someone and what the other knows about me, I think increases in a world populated by such devices.
Awesome.
Maybe an issue.
So thank you so much. Okay, last question.
How do we protect the users that don't want to be involved in this, and how do we stop profiling? For example, if a user has done certain things, it's a very high likelihood that he will commit a crime. There will always be false positives in this one, and that's a real concern. Actually, in the US, there were cases in which software based on learning algorithms suggest to the judge the likelihood of a convicted to commit another crime, and they base their sentences on this decision, even though they don't really know how these algorithms work.
Well, for some people, technology will always be black magic, right? So
the problem is, how do we inform stakeholders? Because they need to make certain times life and death decisions based on that information.
You guys?
So it's always a game. Imagine how you convince them of some other things, how technology can help or cannot help. So after all, it's technology. Some people saw it as black magic, others see technology as white magic. So some will rely on it, some people will hate it. As long as it's logic and arguments should win. But yes, there will be always false positives, there will be always fails, as long as we count on a third entity as human made mistakes. So I'm not sure there is a magic solution for this.
Thank you.
Thank you. So, thanks, guys.
Thank you, guys.
Thank you.
This wraps up the second panel of the day and the last one. Once again, you all know Paul, so Paul, welcome back on stage. He's going to present the following startup pitch.
So yeah, you all know me by now. The next startup, okay, so you've all got maybe production code running, right? So how do you know when it fails? How do you make sure it's gonna come back? How do you basically monitor it? This next startup might be helping you with that. So let's hear what they have to say. Welcome, Dataflow.
Let's give him a round of applause.
Okay, so hello, my name is Hazan Batin. I'm a software architect, and together with my partner Mihuna Toma, we developed Dataflow, a real-time performance solution. Before I go into the details, I will have to ask you a question. How many of you are using monitoring techniques or tools for their online services? Please raise your hands. Okay, there's not too much. Okay, well, it's quite important to monitor your application because normally you want to deliver a seamlessly integrated product and you want to know exactly when the product fails. And of course, you want to know exactly at any given date. This is what Dataflow does for you. So by using customized indexing and monitoring techniques, Dataflow helps you study your service performance and identify technical and structural errors. I will go now to present the main features of the product. Please stop me if you have any questions. So the first part is the monitoring part. So data flow continue tracks all your services latency to find bottlenecks that affect your customer user experience. Each service is monitored by a group of agents responsible for delivering insights like availability, response, and download time. To keep it simple, basically we are doing a lot of requests frequently to your service, and we collect metrics like response time, download time, availability, and so on. The next feature is regarding reporting. This is quite important because you want to know, not in real time, but you want to know the information on any given date. So as you can see here, this is a service monitor for an online retailer, a big one in Romania. This is how it looks. Each dot from there is basically an endpoint, and Dataflow does create this type of reports for you. The next feature will be regarding the screenshot. So with Dataflow, you can collect and organize screenshots of your URLs and detect possible interface and flows in your website. This is also important for you because you are doing a lot of code deployments and so on, and you want to know exactly if it doesn't break anything, it doesn't break the interface. So you can do this by seeing the dashboard application in which you can see the screenshots for your service. Okay, how everything works. So starting from point 1, you can see that the application crawls and monitors your application. It gathers a lot of information regarding this. Then it allows you to visualize it, analyze it, and get alerts. Alerts are really important because you have downtime in production or different other type of failures, and you want to know exactly when this happened, and you want to react fast. And then you can get reports, which I talked about previously. Okay, some information regarding the technology stack. So we use MongoDB with a custom time series schema for storing the data. We use Java for the main APIs. We use Node.js for the agents that does the indexing. Redis as a queue manager, and AngularJS for the UI. That's pretty much it. We are in public beta, so please drop by and let us know what you think about our service. Thank you.
Very much. And good luck. Okay, next up we have another keynote, this time from Cristina Morariu. It's nice to see some girls up here. So let's give her a round of applause. She is an AI enthusiast at SoftVision, and today she will be talking about testing in artificial intelligence in applications. Did I get that right? Yes. Okay. Then I'll leave you to it, and good luck.
Okay. Hello, everyone. It's very good to be here. I am Cristina Morariu. I'm currently working for SoftVision. As a day-to-day job, I'm doing project management, but besides that, I started a community that handles AI stuff, machine learning stuff, and so on. I have a PhD in system engineering since 2013. I got that from Polytechnica Bucharest, and I'm the mother of 2. I have a 9-year-old and a 7-year-old, and actually the passion for artificial intelligence came 2 years ago when I bought my kid a Lego Mindstorm robot, and we thought about it and thought, okay, we have this robot, it's really cool, but what if we could make it talk and interact in natural language? So what we have done is we have connected it to IBM Watson because back then, 2 or 3 years ago, IBM has released its AI services. So we are using IBM Watson, speech-to-text, text-to-speech, natural language classifier, and also image processing. We have managed to get an intelligent robot. And I have been presenting that robot at Dev Talks last year and at Code Camp. So before I start, does anyone has seen me before presenting? Okay. Okay, let's move on. So before we start, I would like to express what we want to achieve after this talk, what's the purpose of the talk, and what we do not want to achieve, to make it very clear what the talk will be about. We will talk about the different type of learning, machine learning, and we will talk, maybe I will bore some of you, maybe I will bring back memories from the mathematics class in high school to some of you. But the idea is to understand the roots of machine learning, to demystify it, to understand how it works, and then to be able to formulate a testing strategy if you are going to build a machine learning system. We will not cover different type of machine learning algorithm. There are a lot of them, and I used to get this question in different talks that I give, what algorithm should I use? Well, actually, that depends on the problem that you're trying to solve, and it depends on the data that you have in order to solve that problem. So if we do not talk about the specifics, I will not be able to give you a clear answer. And we will not cover different machine learning phases, project development phases. We can cover this separately, so if you're interested in this, we can discuss after the talk. So let's begin. The presentation will be structured in these four categories. We will discuss a bit about the environment today, why we see this hype in machine learning, why it's happening, what we see it's happening in the industry. We will try to define the different types of machine learning that exist. We will see how we can test our machine learning application and how we can think about testing it, how we can formulate a testing strategy. And at the end, besides showing you some useful resources if you want to study in more detail machine learning stuff, I will also, I hope we will have time, I will show you some of the projects that I have been involved with. 2 years ago, I also had my own startup, and with that, I managed to deliver some projects using AI services. So if we will have time, I will show you that at the end of the presentation. This presentation and the terms that I will be using are based on Andrew Ng's, I will say NG, but actually it's N course. You can find it in Coursera. It's a free course, and it teaches you the basics of machine learning. So the terms that we will use in these presentations are based on that course. So what is happening now, and what is machine learning in today's environment? As I was mentioning Andrew Ng, he's actually a professor at the Stanford University. He mentioned that machine learning is like electricity, and machine learning will change every industry like electricity changed every industry 100 years ago. So we need to prepare for that. We need to raise our skills considering that, because we as developers for sure will be placed into the position to develop an AI application rather soon. Why is this happening today, and why it didn't happen 5 years ago, considering AI is quite an old domain, and well, it's starting back in 1950. Well, the cloud made it all possible. I'm saying the cloud because of the cloud we have enough data in order to train our systems, in order to have algorithms that can learn based on data. We also have the processing power in order to make machine learning algorithms, and we also have advances in terms of algorithm to make this possible. What is machine learning? To put it in a more precise way, I've noted there the definition done by Tom Mitchell in 1998. He says that a machine is learning with experience E if we can say its performance on a certain task T noted here increases with each experience. Now, again, in different talks that I'm giving on machine learning and artificial intelligence, there is this question that I get: what will happen in the next 5 years? Or when will computers surpass human mind? When will computers be smarter than us? So I have digged this a bit before I came in front of you, and I found this graph. It's actually based on Moore's law combined with linear regression, if you look at the graph. Well, if we consider the advances in the last 100 years and how everything has evolved, we can say that by 2025, we will have the first computer that will have the processing power of a human brain. And if we look at the same graph, we can say that by 2045, we will have a computer that will have the processing power of all the brains in the world. Does this sound discouraging, terrifying? Okay, what are the different types of machine learning? The first class of machine learning, and this applies to neural networks as well, or all different types of algorithms that you may already heard of, is supervised learning. Supervised learning means that we are developing an algorithm and we are training it using labeled data. So we know from the beginning a set of input data, and for each entry we know the output data as well. What's the output of the algorithm? An example that is used in the course that I was referencing from Andrew and G is an example of where you could use supervised learning is to predict, for example, a price of a house, of a car. And in this situation, you would have a large set of data with the features of the object that you're trying to sell. So for example, if you are taking the houses and the housing prediction, the price prediction problem, we would have the house that has a set of features, like the number of rooms, the number of bedrooms, a certain width, a certain garden, a certain location. You can include also the name of the owner if you consider that important. Now, when you're training your algorithm, you would also have the current price that the house was sold for. So using this, you would develop a certain algorithm, and the most simple algorithm that you can think of is linear regression. So you would have certain data, like in the first graph over there, and you would be able to draw a certain line to best match your examples in your training set. Now here, I will stop for a moment and I will ask you to imagine, so what you're seeing on the screen, it's actually a two-dimensional graph with one axis that is the input and one axis that is the output. But in real examples and in real machine learning applications, you would actually, as an input, you would have a vector of features. So it's not only a single value, but it's a vector with several values, as I was saying, different features of the element that you're trying to map as the input of your algorithm. Now, supervised learning can be divided into two main classes. First, you have the regression type of algorithm. And in regression, you would want to find the function that best matches your data, your training data. Based on that function, you will use that function in the future in order to predict future values of different input data that you will have in the future. The second type of supervised learning algorithm is called classification. And here you would have, you would draw a line that would separate the values in two clusters in this example. So you would say it's either a circle or an arrow, again, based on certain conditions, like how close are the dots to one another. And again, if you are given a new value sometime in the future, the algorithm will be able to say if it's a circle or an arrow. Real examples where supervised machine learning is used, well, the most common, and I'm sure all of us are using this, is the spam filter. So in order to classify a message as spam or non-spam, supervised machine learning, a classification algorithm is used, and it will say, based on certain features, like, for example, certain keywords, that's a feature that you would see in a spam email, or certain typos, stuff like that. You can classify if a message is spam or non-spam. In the background, in the previous slide, it was playing a recording of the steps that are done by a supervised learning algorithm in order to classify two clusters of data. Now, unsupervised learning, on the other hand, has much more promise, and it's much more, well, wanted, because you do not need to have labeled data. You have big sets of data, and by applying an unsupervised learning algorithm, for example, the most used one is k-means, you are able to separate the data in clusters. Again, in order to visualize in 2 dimensions, because that's what we as humans are limited to, this is what an unsupervised learning would do. So you have a large set of data, and you are dividing it into clusters. Where we are current examples of unsupervised machine learning, and again, I'm hoping some of you are actually using it. It's Google News, news.google.com. What it does is clustering the data on, it's clustering the news based on the topic using an unsupervised learning algorithm. Another example is data visualization. So, as I was saying, in most of the times, your data has more than 2 dimensions, so more than 1 dimension. Sorry. So, for example, if you were to implement an algorithm and you have 42 dimensions, for example, in a network log, you would want to visualize the data in 2 dimensions to see if you have certain clusters, if you have certain patterns. And in order to do that, you would apply an unsupervised learning algorithm, for example, pre-simple component analysis, in order to reduce the number of dimensions in your data. Another type, well, it is defined that the third type of machine learning is reinforcement learning. The most common framework for this, and I'm sure some of you for sure have heard of OpenAI. It's the initiative that Elon Musk has started, and OpenAI is actually a framework to develop reinforcement learning applications. Reinforcement learning operates in a very similar way to how we as humans, for example, are playing a certain game, and it's using rewards in order to compensate a good behavior. So an agent is actually performing an action on the environment. If the action is taking the agent closer to the goal, the agent would receive a bonus, a reward. If it doesn't take the agent closer to the reward, it will not receive that bonus. And here I also have an example of, it's the mountain car. You actually can find more examples of reinforcement learning implementations on gym.openai.com. And you have this car that doesn't have the power to climb the mountain. And it actually needs to take inertia by going backwards and taking up power. As I remember, the game was managed to be resolved in 100 steps. And you can find the algorithm and the data set that was used for the implementation again on the net. Everything is open source, so you can use it for your implementation as well if you want. Lately, I have started to search a bit more and to read about biological inspired algorithm. I'm not sure how many of you have researched this field. Very cool. Yeah, so what I have been looking at is hierarchical temporal memory, HTM. It's an algorithm that it doesn't use mathematics to arrange the data on a function, on a mathematical function, but it actually uses a large space to show the connections between different data points. And they have quite amazing results. So if you want to try it, there is an HTM studio, and I will show you how it looks at the end of the presentation. You just need to have your data set. You would load your data set as a CSV file, and it would show you what anomalies you have on your data. And if you have enough examples, it will also be able to predict you future values for your data. There are some limitations if you want to use this system. You only can map one feature. So for example, your CPU usage, or I will show you an example with a number of bike rentals per day. And it's also, your data needs to be time series. So it will predict the values in time by looking at different time slots and seeing how the data is behaving. One second before I go back. This is an example of how HTM is actually predicting the data. So after running for, I think, 5 hours or so, it was able to, the green line over there in the graph, it's the real value, and the purple one is the predicted value. So you will see in certain cases, after 5 hours of running on the data set, we see that the algorithm started to predict the value before the value actually started. It starts by copying the values and copying the behavior, and then at a certain point it starts to learn, and it will predict what the next value will be before the event happens. And if you look at how the data is looking and what patterns we see in this graphic, it's for sure not an easy task to find a function that would mimic something like that. So what are the possible problems that we can see in when working with machine learning algorithm? One of the problems that you need to look for, and especially if maybe you're testers, is overfitting. So in machine learning, comparing to traditional software development, you do not need to look only at the software, but also at the data as well. So you have first your software, your piece of software, and also you have the data and how the machine is learning your data. In an overfitting situation, your algorithm is trying to match every single point in your training data, but it will perform very poorly on new data that you will give to your algorithm. These are two examples here. If you want to see, if you find yourself in a situation like this, it's a best practice to plot your data. Just plot it, see how it looks like, see how your algorithm is matching your data, and try to get, well, possible corrections based on this scenario. Another common situation that we can find ourselves in when we are dealing with machine learning applications is underfitting. Our function is too generic, and it matches all the data that we give it without being too specific about our data. Now, maybe you were in this situation as well, but when you're developing machine learning applications, when your algorithm is performing very poorly, the first thing that comes into your mind and in your stakeholders' mind would be, let's grab more data. We do not have enough data. Well, if you find yourself in this situation and you are underfitting the data in the training set, it doesn't matter how much data you will give your algorithm, it will still perform poorly. I was saying that at the beginning of your project, of your machine learning project, you need to think about the testing strategy. Now, a best practice is to separate the data that you have. So at the beginning, you have the problem, what problem you are trying to solve. We have the data set, and that data set will be used to train our machine learning algorithm to see for example, what's the best function that matches our data. Now, a good practice is to divide your data set into parts and leave certain data in order to test your algorithm. So you would use 60% of your data in order to train the algorithm and leave 20% of the data to pick the best option, the best algorithm from a set of algorithms that you are maybe considering, and 20% of the data in order to test your algorithm. In unsupervised models, the situation is a bit more complicated. And there are, well, if you want to test your algorithm, one option is to manually label a set of data and use that in order to test your system. Or you can also, usually when you're using an unsupervised model, you would have another system that is using your data, and you can evaluate the performance of that system. And to summarize a bit what we need to look for in machine learning applications, if we look at this drawing, and it's actually done on the blackboard that I have at home, I strongly encourage you to buy one. It's quite awesome. So you have the source code that is in the middle, and it's the traditional way. We have the algorithm, the code. You have the test data, and using your test data, you are building a machine learning model. Now, while your application is in production and users are actually using your system is learning, and you would retrain your system, and you will see that actually when you're testing your result set, so the results of your application will not only depend on the code that you're writing, but will also depend on the machine learning model that you're using. So you have two things that will change simultaneously compared to what we had until now, when only the code was changing and it was easier to understand it was easier to identify a problem. Another option to test your system if you have a more complex system is to use the ceiling analysis. If you, for example, have a face recognition system, you would, when one option is to take the camera image and subtract the background, then you would detect the face. From the face, you would detect the eyes, the nose, the mouth, and so on. And in the end, you would do a logistic regression, for example, to identify a person, if the person is a person or not. Now, if you want to test your overall system and you want to understand where is it worth investing your time in, what part of your system you need to improve, one option is to evaluate each component individually. So I know the overall system performs at 85%, for example, and I know the performance of each individual system. So if I want to improve this example, the system in this example, I would pick the pre-processing component, so the one that is removing the background, because I would have the larger gain if I improve that. Oops, sorry about that. Very short, because I want to show you some examples as well. So if you want to go a bit deeper and to understand the machine learning and all the AI stuff that is going on and understand it at the core, I strongly encourage you to take the Andrew and G's course on Coursera. It's a free course, and it offers you all the background mathematics in order to understand almost every algorithm that you will see after that. A very good collection of materials. It's on, you can find on GitHub, on the OpenAI machine learning curriculum. It's very comprehensive, and it has all these materials from blogs, videos, and so on. And now, let me see how I can do this. First, I want to show you I know that we have talked about a lot about IBM Watson and different services. I want to actually show you IBM Watson and how it extracts sentiments from text. I, as a manager, I would really help to know the sentiment that my client has towards me from the email that the client is sending. So what I can do, and you can do this by building your own system as well. So I will just go to Google News, for example, since we talked about it, and I will, well, search for not Obama, but Trump, because he's really famous and he's famous. I would take the text, and this is, you can actually see the, well, you can try it on your own text and also see the JSON that is returned. I will place the text here, and here it took a bit. So you will see that on each entity that is extracted from the text, I have a relevance, a sentiment, and in this situation is positive. The type of object that has been identified, and the emotions that the text has towards that entity. So I have anger, well, quite a bit of anger, disgust, fear, joy, sadness. This is what IBM is returning. It's just an example. Microsoft, Amazon have similar services. So if you want to build an application really fast, you can use sentiment as a service and test it on your own text bits. In my experience, we have used this in, it was actually a blog from India. And it was, well, different people would come to this blog and they would say experiences about their travel to India and different locations and stuff. And we have done a pitch to show what's the sentiment towards that place. So for example, I really liked it, or I hate it, don't go there. As you saw in different technical speeches today, you can do this with your own software, so it doesn't need to be on the cloud. But again, just to know that it exists. Another example, so this is actually an application that was delivered, as I was saying, 1.5 years ago. It was for a group that was manually identifying brands in text. And they had all these people that were reading magazines like Vogue and Marie Claire and would extract brands from those magazines, because brands are not widely made public on the net. They are made public on these magazines. And again, using I would use the same text as I had copied. Again, using AI services, we managed to get them a platform. Just input the text here, and it would extract the possible brands. And as you can see, it identifies the brands quite well. And the last example that I will show you, this is again, a technical pitch that was done for a company that it's in the standards business. So they are evaluating if another company is ISO compliant or not based on the documents that they provide. They have been doing this manually with people, so the person would go and would read all these documents and would know the ISO standard and what they need to look for. Now, again, doing concept extraction and cross-searching between the standards and the real documents, we would get a report like this. One second. This one doesn't have any entries. Maybe it takes a while. But what it does, it actually mentions in a report what's the match and what's the score. So a human would only go in the report and see if it's correct or not. And with that, I can show this to you later, maybe, because I finished my time. Thank you very much. And if you have any questions.
Thank you very much. It was a great presentation. Let's give her a round of applause. We have time for 2 questions, 2 quick questions. So who's offering? Okay.
How does HBM stack against SVM, state vector machines? They seem to be pretty similar. Why would I pick a HBM?
HTM, it's support vector machines is still mathematical. So you would use, it actually divides, again, the data set into 2, and it will classify then your data, but it's still a mathematical approach. HTM, it's not mathematical. It doesn't have anything mathematical in it. It's just about data and representing the data into dendrites, into a large space.
So basically it would be more scalable when you have diverse data compared to state vector machines, which are more predictable.
It's totally different. If you have temporal data like a log, a CPU usage over time, HTM, it's the best approach in order to predict anomalies. I didn't manage to show you that, but I can show it to you after the break, after the speech. Support vector machines would be to classify the data.
Okay, let's just say I had something else in mind, but we can discuss after.
Okay.
You can always catch her on the afterwards and ask all the questions. Anybody else? Okay. Go.
Not yet.
I'm curious to see what that ends up with. Okay, thank you very much.
Thank you.
Great, great presentation. Let's give her another round of applause. Coming up next is Paul again. He's going to be introducing the next quick startup pitch. So Paul, come on stage.
I'll let the guy set up and I'll be down here this time. So for the next startup, I'm just going to give you some keywords and I'm going to let Raresh then fill in the blanks. So it's about music and artificial intelligence. Raresh, go ahead.
All right. Mushin is the first DJ powered by artificial intelligence. People love to party. As a matter of fact, right now, there are tens of thousands of parties happening all over the world. And still, how many times have you been to a really cool party and had to listen to some really shitty music? Remember hustling the guy with the laptop for a different song? If you can't afford a professional DJ for your private party, then playing music for a group of people can be a really big problem. Well, we built a product that solves this problem. Mushin is an artificial intelligence that detects the musical preferences of people at a party and generates a dynamic playlist with music that everybody would love to hear. All you have to do is to launch the Mushin app and invite friends to join in. Everybody at the party can use the Mushin app to connect with their music streaming services like Spotify, Deezer, or the Romanian Zonga. Mushin gathers musical preferences from all the people at the party, and based on a really cool machine learning algorithm, it generates the perfect playlist that everybody at the party would love to hear. And it's doing this in real time, so that every moment somebody joins or leaves the party, the algorithm adapts the playlist by choosing the next perfect song. All right, we created an artificial intelligence deciding on the best music to be listening to. But we don't leave it all to the AI. We let people interact in a gamified environment. People can influence the playlist with a simple swipe. Just think Tinder for music. Swipe right and the song goes up in the playlist, swipe left and the song goes down. We make our product available under a freemium business model. People can use Mushin for free to power their private events and house parties. In order to get access to premium services in a B2B context, users will pay a small monthly subscription fee to play music through Mushin in their restaurants or bars or actually everywhere you can listen to music. We are a group of tech geeks and music enthusiasts. We've been working on this amazing project for almost a year now, and we already did pilot events with incredible results. We are Mushin, and we are changing the way people collectively listen to music. Now, let's see how this amazing technology works. All right. You can see now the DevTalks music. Okay. You can see the DevTalks music party. Just imagine that this is your private house parties, or okay, it's the playlist generated for a special event. I already connected to this party using my Facebook account, and you can see now. 1 second. Trying to show you the screen of my mobile phone. Okay. Yeah, air server issues. Anyway, you can see some people who already checked in at the event, and you can see the special playlist, the real-time playlist that Mushin generated in real time. I wish you could see the screen of my iPhone, but you can actually connect in real time right now using the Mushin FM app on App Store and Google Play and swipe to a couple of songs. For example, Pepino Galilardi, I'm not really in the mood for this. Lauryn Hill, Feeling Good, that sounds pretty good. Okay, Pat Bantnar, David Bowie is always a good one. Okay, so I just swiped through a couple of music, and in real time, machine will simply adapt the playlist based on my preferences and everybody else's preferences. And of course, you can listen to the music. Okay, thank you.
Thank you, Raresh. Great presentation. Great idea, and good luck from... Okay, thank you. Let's give him a round of applause. Just a quick update to the schedule. We should have Christian Vikash now and his keynote on Catalyst machine learning on satellite data, but he's going to be up next. So right now, we welcome on stage Sergiu Negruț.
I need to take a slide sorter, something?
His keynote is on innovation and money making, so let's give him a big round of applause and good luck.
Okay, thank you. So that is Sergiu Negruț, and well, I'm going to talk about the simple things, which is about how to make money. The complicated things with the algorithms and so on. These are, very deep questions that we all struggle with. But the very simple thing, how to make money. Can we actually make innovation and money at the same time? Or is it sequential? Or none of the above? Which we always do in our day-to-day life. Anyway, I have a very interesting job. I'm a business angel, which means that I'm investing in a number of companies that I help grow. I'm investing a lot of effort and some money with a clear goal of making, I'm listening, a fortune, of course. Yeah. So, in my portfolio right now, I used to be a very serious person. So first, I'm a graduate in computer science, so I kind of share certain interests with you. Then I've been a very serious person, working for a multinational, doing business development for the multinational, then working for an entrepreneurial Romanian company, then selling the company twice to private equity investors and so on, and I made some money. And rather than, buying the extra house and the extra pool and the extra car, I decided to invest in companies. So I have a very diverse portfolio. I have invested in fresh food with Frou-Frou, in affiliated marketing with 2Performant, and actually we are the market leader, and we have intermediated some 2.6 million transactions in the Romanian e-commerce so far. In healthcare, in, of course, software, Softelligence, where we have a very interesting fintech product, which is Fintech OS, that has just been launched. We're already making $1 million recurring revenue this year, so we are on track to be big. Euro IT Group, which is a company that I built in the States, in UK with a partner in order to sell Romanian software with British accent. It sells more expensive. Super. In my free time, obviously I have a lot of free time, I teach. I did an MBA early in my career with INSEAD, which has been ranked for the last couple of years as #1 business school in the world by Financial Times. It's never been before #1, but it's always been in the top 10. And I've been brainwashed severely during my time in the MBA. So this is what I'm trying to do today, and brainwash everyone a little bit about how to make a fortune. Thank you so much. Okay. In my free time, of course, I'm helping some companies grow in, as in their board of advisors, as a mentor, or as a tiny, tiny, tiny shareholder. And there are a few other companies that I have invested in. So what did I say? I'm a business angel. So in the morning, when I wake up, I look like this. Absolutely. You're very unlucky to see me in the afternoon. It's somewhere a sort of a journey where we are struggling to achieve our biggest hope. Because, we invest in companies with a goal of creating something. There is a hope there. And it's always like in, like in Star Wars, with many white guys, the evil ones, led by a black big thing, hardly breathing, and the good guys on the other side. And we're kind of used with the good guys to win, but what's the percentage of startups that survive the first 2 years? Well, let's say 10 to 15%. Let's be more optimistic, okay? What's our hope? Is our hope innovation? Yeah, of course. We're all after the cool stuff. Nobody wants to do the next outsourcing boutique. Everybody wants to do the next amazing product. How much money do we make by making the next big product? So this is one hope. We hope to have innovation. We also hope to have knowledge. Yeah? We read about stuff. We follow courses. We try to get smarter. We try to get better at what we do. This is a hope. Some of us actually spend an amazing amount of effort just trying to be smarter. Okay? I would have put a big pile of cryptocurrency here, but I didn't know how to figure it. So for the time being, we're still into the old, big pile of cash. Some of us are in it for the money. Okay? And basically, this has been said before by people much smarter than me, that our problem is to turn our questions into cash. And this is actually Tim Brennan of Apple that has, the chief designer there. I like this picture very much because it has a very interesting translation into Romanian. To make din ceva bici. We are trying to do that in our business. I'm a very old guy. If you have taken a look at the first slide, my email address is sergio@gmail.com. Now, I'm that old that when I was young, people used to read books. Okay? I'm sure it doesn't happen to you. Yeah? But when I was young, I used to read a book. I wasn't that old, but anyway, the book was published in 1865 by a bearded guy, a hipster. And the bearded guy, imagined, had the amazing idea of a trip to the moon and back. By three guys, three Americans, flying out of Florida with a big shuttle. And the idea was it innovation? Who was the guy? Jules Verne, thank you. Okay, was the idea new? Was it innovation? It kind of was. Did Jules Verne make money with it? Of course he did. He sold books. Okay? About 100 years later, a tiny agency from the States, NASA, actually put a rocket on the moon. Similar size, similar weight. Three guys, American guys, flying out of Florida. They succeeded it. Was this innovation? Yes, it was. Were they making money? No, they were spending billions. Okay. A few months ago, a good friend of mine, a colleague from the MBA, thought that it would be a very interesting thing because the moon exists and the technology is there, and he had an undergrad in aerospace and had a colleague with an undergrad in IT, so they decided together to put a rocket on the moon. And because Kickstarter was there, they decided to raise money on Kickstarter to put a rocket on the moon. And the goal they wanted to achieve was around £1 million, which would have helped them to, put the rocket on the moon. They failed. So there is a happy ending. They failed. They didn't do that, but they raised a bit more than half of the amount that they wanted, which is already amazing. So is this new? Not really. Is this innovation? Yes, probably, because you're combining things that exist and have been done by state agencies with means of financing that have been provided by the environment, and you put the two things together and you, ta-da, get something new that can be sold and, you get people interested in it. That's very interesting. Because my thesis now is actually the fact, and this is actually by a guy that is much smarter than me, that creativity is thinking up new things, but innovation is actually doing things. So innovation is good when you actually are able to do things. And not all innovation is actually able to be transformed into money. And what's the connection? How do you actually distinguish between innovation that is there for the sake of it and innovation that is there to make money? Basically, you have to follow the trends. You have to do things rather than think about things. Okay? I lived for a few years abroad. I moved back some 10 years ago to Romania from Switzerland. And I had a friend at the time who told me, Sergio, you're an idiot. And I said, yes, tell me something I don't know. Tell me why. And he said, look, if you go back to Romania, you're going to, just give away 10 years of your life. And I looked at the statistics, and indeed, the difference in life expectancy was 10 years at the time between Switzerland and Romania. Guess what? Today, it's only 8 years. If we live about 250 years, the difference will disappear. No, the guys that are better at maths than me would have calculated that to be wrong by now, but anyway. So we are really, really good that the neighbor's goat doesn't look much better. Yeah? So the neighbor's goat has pretty much the same life expectancy as ours. And this is a fact that is led by technology, our ever-increasing lifespan. And the bald guy that I invite here to you is in a cartoon a couple of years ago, Big Hero 6, and this was actually a personal healthcare companion. And the guy in there, this is the equivalent, if you want, of the Jules Verne novel. So the guy in there, when he had a sort of healthcare problem, had this robot that intervened to fix him and collected feedback after fixing him. Now, we all know it's going to be like this. So understanding long-term what the trends are is good. But having the idea as Jules Verne had, was it possible to be implemented at the time? Well, I have another example, which is, by the way, very interesting. I'm Mitica, I'm from Bucharest. I'm not native from Bucharest, but I moved there many years ago, so I think I'm from Bucharest now. So a good friend of mine, some 8 years ago, decided that there is a big opportunity to make money by creating a restaurant, a club, in the old town in Bucharest. Does that sound like a smart idea? Kind of. Yeah? So he started a restaurant, lost some 40,000 euros for the entire summer season, closed the restaurant, sold it for a loss at the end of the season, and said, this is never going to work. The next year, the old town in Bucharest became what it is today, a place where everyone makes money. So time to market is actually much more important than the quality of the innovation. Are you able to extract value now from the innovation, or you have to postpone your idea until, the apples are ripe? Let's look at the trends. In 10 years, the thing that we call a phone has changed from being something that was used to talk with into something that is used for many things. Is this amazing digital machine that keeps me in contact with your digital agents, let's call them phones. So phones are no longer what they used to be 10 years ago. Friends are no longer what they used to be 10 years ago. Network is not the same. Location is not the same. Payment is not the same. It's not about counting cash. It's like is not, share is not. Agile means something different, as you well know. Even gender, not exactly what it used to be 10 years ago. Now the question is, I was brave enough to change my ID, and the administration was optimistic that they would have to use the same kind of plastic 10 years from now. Let's forecast. We know what has happened over the last 10 years. What is going to happen for the next 10 years? What communities and jobs and money will mean? Will education be impacted? Will healthcare plans be something that we depend on from the employer or from the state, or is something far more flexible? Would we ever go to the dentist in the fashion that we go today? Will we pay taxes? To whom and how? What will be a social contribution towards what kind of entity? What a country will be at the time? You see, we are in the economy where it is in fact our choice, and it is definitely our employer's choice, where to locate us. Because the work in itself does not depend on this particular piece of land, and it does not depend on this particular piece of infrastructure that the city gives us, which means we have the power. What will human be in a few years from now? We don't know yet, but follow the trends. Trends are there. Trends are in the literature. 10 years ago, there was a movie, Minority Report. They had self-driving cars. We have self-driving cars with no extra duty in the car. We have big fleets of drones that communicate among each others. We have factories where no one person can be seen. We have microtechnologies. So we have to follow which are the technologies that are already making money somewhere, where there are already some applications that can be turned into cash. Because if you do not see already in the world some application of that technology being turned into cash, it doesn't make sense to pursue that technology. We live in Romania, which is amazing. Full of, what was that? Hard-working and hospitable people. Yeah? That's what we learned when we were in primary school. Okay, in Romania, we're lucky to read Tomorrow newspaper. Tomorrow newspaper is being published in Germany. The day after Tomorrow newspaper is being published in the States. We know what is happening. We just have to follow the trends and ride those trends. And now, the academic in me comes with this awful slide, which I'm going to make explicit with the next one. There are waves. Technology comes in waves, So a certain technology reaches maturity. At that point, there is already a new emerging technology that is inferior, but will eventually outgrow the other one. Think of portable cameras, okay? At some point, portable cameras appeared, digital cameras, okay? They completely replaced the analog cameras, but they were eventually replaced by our phones. Yeah? And there is this dilemma zone where companies don't know exactly what to do. Will I still pursue the technology that I'm using today, or will I switch to a new one? And sometimes you see heroes. You see heroes that decide to actually resist and battle to preserve the industry that they believed in. Anyone who had a Nokia phone at some point in their life? Okay. So technology is there at certain moments in time, but that part of the technology is going to be outgrown by something else. I'm going to give you a different example than Nokia. I'm going to give you the example of Netflix. 6 years ago, Netflix was a DVD rental shop. Big, very big DVD rental shop. But they realized that the way that information is consumed nowadays has nothing to do with DVD rentals. So they decided to move all their efforts out of the DVD rental into something new, into a new space, of digital content production. Digital content production, one day, listed company, what happened to the stock? Value of the company dropped by 80% in 1 week. Luckily, they kept the CEO. And then, came House of Cards and other interesting things. People look at the business that is generated through technology today and through innovation. And in fact, they look at organizations that are able to transform technology and innovation into money, that are able to adopt technology in a way that allows them to take advantage of it and transform it into a fortune. Funny enough, there are very few things when McKinsey, the company that is famous for the fact that no one has ever been fired for choosing to work with McKinsey, has created this digital quotient. And funny enough, only 2 small things in here about data-driven decision-making and automation and a bit of IT infrastructure are about technology. Pretty much everything else is about how people work with each other, how strategy is fit, and how the organization is actually developed. And today, we learn from the IT industry, and we do agile business development. And these guys have realized that you cannot keep the IT, the traditional IT, and the innovative IT together. You have to have actually 2 IT functions within a company. Because it's one thing to keep the system that keeps the company alive and working full speed with all the clients and deliver results every day. And it's a different thing to create the future. And you need, by the way, different focus and different kind of people. So you start doing lots of things. You need appetite for risk. You need to understand to take risk. And we, people that have done computer science, used to be pretty good students at some point. We learned very well in school what? To do very well things that were assigned to us by others. We are not so good at doing things by ourselves that have not been asked of us. But that is innovation. So, at the end of the day, the world is changing. About a couple of months ago, I had to pay some taxes and get a certificate from the local tax authorities for that. So I had to go there, wait in line, get a ticket, show back there. I calculated it would take about an hour and a half. Went back there, an hour and a half later, met a lady, very nice, very polite, spent some 15 minutes with me, took some documents, filled in a form in her computer, printed a form, got a couple of colleagues to sign on the form. Everything was in their databases, you understand? Okay. So that lady, for 15 minutes, did not spend 1 second thinking. She did exactly follow an algorithm. No? Very simple algorithm. No thinking required. In fact, she did a job that was a lot more simple than the job of a robot. Okay? Now, the question is, why would we and our employers pay anyone to do that kind of job when we run the risk of illness, absenteeism, strike, people want higher salaries, they want to go on holidays, and all the awful things that we don't want from our employees ever, right? Why don't we pursue the other route? And the reality is we do pursue the other route. But there is a twist to it. This is we are dangerous people, we IT people, because we build these things. And these things kill jobs. Huh? It's very interesting. So in fact, we are in a world and we build the future in a way. And because we build the future, because we are smart people, we look at the things that we know. Yeah? And we want to learn this part because it's really challenging. And it's only so few people in the world that can do that. You know the story that 10% of the engineers in the valley, in the Silicon Valley, are Romanians. Yeah? Okay. Think, what is the percentage of business people in Silicon Valley that are Romanians? So my challenge to you is to understand that we kind of carry on a battle where on one side we have digital robots and algorithms, the other side we have paper and coffee and a little bit of brains. And there is a story that dates back to the time when I did my degree at Polytechnica University in Bucharest. And the story goes like this. There was a famous artificial intelligence professor at the time, Jumale, who was very happy to get to form his own small department of artificial intelligence. And he was so happy that he took an A4 sheet of paper, wrote on it artificial intelligence, and stuck it on his door. Now, the guy that was teaching electronics and was sitting on the same corridor opposite smiled, took an A4 sheet of paper, wrote on it natural intelligence, and stuck it on his door. So my question to you and my challenge to you is, what kind of intelligence do we want to build? What kind of intelligence do we want to pursue? And the answer is both. So next time, when you see change happening in the world, I challenge you not to look only at the technology part, but look very carefully on the business part. What animal do I have here? It looks like an ostrich, but it's a myth. The ostrich doesn't hit his head in the sand. The only animal in the universe that does that is Homo sapiens. It's only us that are so smart that when we see something happening that we don't want to believe, we prefer to hit our head in the sand. Changes are happening, and we are the only species who choose to make shit up and believe it. What is this? This is a horse. Some people may think it's a unicorn. No? But last time when I looked in all the stables around me, it was a horse, a donkey, a mule, a zebra, although zebras in our cities look different. Yeah? So take a look at the species that are around you. What are the chances of actually seeing a unicorn in the stables around us? Pretty small. Is it safe to assume, when you're a business angel or a VC, that what you're seeing is not a unicorn? It's quite safe. It's a horse. Yeah? My advice is look at things that have been created before in some form and look for an improvement. Look at all the famous business successes in Romania, all of them. Yeah? Dedeman, original concept? No. Autonom, rent-a-car. Market leader in car rental in Romania. Original concept? It's an enterprise. No. Bitdefender. Is it the first antivirus on the world? No. All the businesses that are big and famous in Romania, irrespective where you get them, they are not an original concept. Let's make a step forward. Is Google the first search engine that appeared? No. Is Facebook the first social network? No. Do we see a pattern? It's about, getting something that someone else has tried, improving it with the business mind, and creating a money-making machine out of it. In other words, it's seeing the change in the universe, understanding where the next wave of change is coming from, and getting prepared with the proper equipment to ride the wave rather than be torn apart by the wave. So look for your wave. That's my advice. We have a management program starting in Cluj in September. It's a 4-month program, 21 full days, and we are pretty good at it. But the final message that I have for you is not that one. It's the fact that as you start building your career, as you start building your money-making career, not only your technology career, it's as fast as learning anything else. And of course, you have to be a bit patient. You have to make mistakes. A lot. But the mistakes that we have to make have to be a bit smarter every day. Thank you. And Sergio at Gmail, if you need me.
Thank you very much for the speech. It was great information. Thank you very much. And this being said, we're getting ready for our last keynote for today. We are welcoming on stage Mr. Cristian Vikash. He's going to be talking about machine learning on satellite data. So, welcome. Okay. Either way works. I was inviting you to... Okay. Let's give him a huge round of applause.
Good afternoon. My name is Kristi Vikash, and I'm a software engineering at Catalysts. Today, we will talk about a project, CI for Clouds. We tried to detect clouds from satellites. We have these satellites that spins around the globe and take pictures of Earth. And we tried to see clouds. First, I want to talk about my big family, which is Catalysts. We have a big family of software engineers. We have a number of projects. We work, for example, with Porsche, with Schackemeyer. We do custom-made software. And amongst these clients, we have two, let's say, unicorns, not quite, 2 stars. We have some projects with European Space Agency and Hyperloop. This is Elon Musk's Hyperloop. We are pretty proud of them, so all the time we are doing a speech, these 2 icons are there. This presentation is about machine learning. I want to try to incentivize you to learn machine learning. We have all kinds of devices, smart TVs, smartphones, smart fridge, smart cars, but they are not really smart, are they? What customers usually want, they want to talk to a device, and they want a meaningful answer back. We want autonomous driving. These are the things that are really, really smart. To talk to a machine at the phone and to have the answer back immediately. Not, please repeat your question, blah, 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 blah. And the only tool that I know of that can achieve this almost human level interaction is machine learning. There are a lot of toolboxes around. A lot of toolboxes, a lot of tools, but there is no real know-how or not easily accessible know-how on how to put all these tools together. I want to stress out one thing. In my opinion, in my humble opinion, machine learning is the new user experience. It's the new mobile versus web. It's the new web versus desktop application. It's the new thing. If you don't have it, you're going to be out of job. Not quite, but as a company, if you don't have machine learning inside, and when the client comes, oh, you know, I want the feedback to be analyzed, and I want to know sentiment analysis, for example, etc. It's a requirement. It's already a requirement. Let's see what it took to learn or to do machine learning. The only thing that it matters is enthusiasm. You have to have enthusiasm. Why? Because machine learning is tough. How tough? NP hard. It's a joke. The point is that you will hit a wall. As soon as you get some data around and start doing some machine learning, you will hit a wall. Oh, the performance is bad. Oh, it doesn't work at the customer. Oh, it doesn't work this, it doesn't work that. Oh, I don't have enough memory. I don't have enough hardware. I don't have enough hard disk space. Oh my God. So you have all kinds of walls that you have to pass through. You have to go around them, etc. And you need enthusiasm. You need enthusiasm because there will be a lot of setbacks and a lot of failures. And this brings me to the, let's say, motivation about this presentation. I want to talk about failures in machine learning, especially how we almost fail our project. So imagine that this iceberg is the amount of work that you do for a client, for a machine learning project, for a client. This is the amount of work that stays in-house. Dead code, tried experiments, and that failed, etc. And this is the only part that goes to the client and maybe gets paid. So you have a lot of failures and hopefully in the end, maybe a bit of success or maybe a little more success. So enthusiasm is really important. Okay, back to business. CI for clouds. We want to detect clouds from satellite pictures. This is a satellite, it's called GOSI. It takes picture, it stays in one point above the Earth, and it takes pictures like this over Korea, Japan, here is Japan, and part of the Asia, China, more specifically. And clouds, I mean, duh, whitish stuff. They have a very specific definition. You have to have solid or liquid water on the atmosphere. So this is the, let's say, rigorous definition of the clouds. But everybody can see that there are those whitish stuff up there. So what we did, well, take this picture, draw some, gather some data, basically get some points with blue, some clear sky points, with red, some cloudy points, throw in some machine learning, and 99% accuracy. So this was 1 month into the project. We were done. It was a 2-year project. We got the funding, and after 1 month, we were at 99%. Ish. We took a closer look at our data, and here is an example in some Gobi desert, I think. I hope I'm not mistaken. You see ice, you see snow, and you see clouds. Can you tell me where are the clouds? No, we can't. I can't. The expert that we talked with, he couldn't. Actually, the cloud is here. Okay? So, machine learning was good. Okay, 99%, but we didn't have enough samples. We just labeled what we thought it was cloud, but in fact, this could be a cloud, this could be a cloud, but it's not. So we needed more data. Meet Calypso. Okay, this is a problem here. I don't have the pictures in my PDF. This is a satellite that shoots a laser beam on Earth and listens to the echo. So this satellite knows precisely what's in the atmosphere. Are there clouds? Are there, I don't know, dust, smoke, and clear sky, nothing, only pure air. So he can tell. But the problem is that it shoots a very, very tiny laser beam over the Earth. It spins around the Earth. And let's say we have this data collected from Calypso, and we overlapped it with our GOSI image. We got, again, 99-ish accuracy. Okay. But we took a closer look on what we had. Okay, this is a bit of a dramatization here. We took a closer look. For example, how hard, this is a picture from Weka, I hope you recognize some of you. How hard is for a classifier or for anybody to predict that this point, for example here in this blue line, is clear sky, knowing that all the surrounding pixels are clear sky? It's trivial, right? I mean, you cannot have one pixel which is cloudy and the other one which is clear sky. In general, they tend to aggregate together, right? So it smelled like overfitting. This is a big scary monster that happens to all of us who does machine learning. It's right after the couch, right under the bed, right under the keyboard, waiting to bite you, okay? So now this is a dramatization. We knew from the start that this could be the case, and we prepared some geo and time-aware cross-validation. That is, we split the data in such a way that our test data was elsewhere than the train data and in a different time location. And we did, well, of course, we raised some learning curves. If you knew the NDU-NG lecture, you will recognize this graph, and it tells us we need more data. So meet MODIS. This is another satellite that spins around the globe, but it takes pictures like the first one. It takes pictures in like 20 bands or so, and it has special filters that can detect the water and the state of the water and the temperature of the water, etc. So it records some physical parameters, and it can tell with, I don't know how much accuracy, 90, whatever, if let's say that zone has a cloud or not. Okay, we get some MODIS data, overlapped it with GOSI, and we got a pretty nice picture. All the GOSI area was covered. Okay, and we did some, let's say, data analysis, whatever. We looked into the data and we saw this thing. I mean, on the left, you can clearly see a cloud. You can see even the cloud shadow. But the MODIS tells us otherwise. Okay, in fact, it tells us garbage. There is nothing here that resembles a cloud or this area. What happens is that we have a parallax effect. Okay, we have two satellites that are looking on the Earth from two different points of view. And one can see a cloud in this position, right here, for example, and the other one a few hundred kilometers away. And this is the case. This is the case, and it happens on the sides of the image, let's say. So we have to filter the data. So we filtered the data, we cut out a lot of data. We still got, I don't know, 10, 100 million samples or so we still got data as a volume, but we lost a lot of quality. For example, we lost the desert. Okay, this was really, really painful. We lost the desert. There is no ice, because somewhere here you have the tropics, or somewhere here, I don't know exactly. The point is that we lost a lot of quality. However, okay, we lost quality, let's see what happens. We finally did machine learning. We finally did machine learning. We got several algorithms. We had a cluster. We have some two boards, Titan X from NVIDIA. We did from logistic regression to deep learning. We tried them all. Okay, almost all, because we had some constraints. We had that much data that we cannot load it in the memory in one step. So everything has to work out of core, from the randomization to training the trees. So you see a lot of ensemble methods here and methods that can learn, let's say, online learning. Okay, we did this. We throw everything in. We let it run. We did hyperparameter search. We did this impressive time geo-aware cross-validation. And we got around 75%. It was disastrous, okay? A lot of computing power, a lot of data, and okay, 75 or 70%, what happens? And we realized that Băsescu was right, winter is not like summer. We plotted a chart with clouds in deep red in winter, okay? So this is what satellites, what the intensity of the light of the cloud in winter. And this is with dark green, clear sky, so land, reflecting the light in the summer, okay? How bad is it? It's very bad. I mean, the land in the summer is brighter than the clouds in the winter. And this messes up the classifier. This messes up, I don't know how we get to 75%. We did another thing. We tried to vary the time delay between the test set and the train set. And the farther we get with the test set, it worsened the results. So if we were trying to predict the next day, it was, okay, 80 something. If we were trying to predict middle of the summer, nonsense. Okay, we have a problem. We have to measure how much light comes into Earth. I'm pretty sure that if we Stack Overflow it, we will get some meaningful formula or piece of code that just have to be copy-paste. Bullshit. It turns out that it's an open problem. It is like egg and chicken, you know? Which come first, egg or chicken? A philosophical question. We have the light that comes from the satellite, it passes through the atmosphere. It is reflected by the Earth and again through the atmosphere at the satellite. So in order to know what's in the atmosphere, you have to know what's on the land. In order to know what's on the land, you have to know what's on the atmosphere. Okay. We tried to implement some algorithms that we found in literature, and we got some recommendation from some people who really know this radiometry stuff. And we got some improvements, but mild improvements. Anyway, we're software engineers, we're not scientists. We're not up to prove anything, we have to make something work, right? So we did a hack. We took 30-day pictures from 30 days, and we computed an average, okay? We computed a harmonic average over these 30 days, and we got a nice, clear picture. No clouds, okay? We artificially removed the clouds. We thought, okay, this is an egg-chicken problem. What if we approximate the egg and maybe we will get the chicken? So this is what we did. It was pretty compute intensive. And we got at about, I don't know, 90-something%, okay? But we took this data and we ran again the pipeline. Okay, guess who was the winning algorithm? Deep learning, anybody? Decision stamp. Okay, this was the what the fuck moment number 3 in this project. It was decision stamp. And we realized that, okay, we gathered that much domain knowledge and we integrated that much domain knowledge into our problem that it was trivial for the machine learning to solve. It was trivial, a decision stamp. It just had to learn a threshold, okay? This was nice, but the project was ended. And it was a bit of a failure because, let's say, the part of the iceberg that was on top was a bit, let's say, too low that we expected. Numerically, we have beaten the current state of the art of the existing solution, but not big enough difference so we can say success, decision stamp rules. On the upside, we found, or our partners found some really hard scenarios where our machine learning, our decision stamp crushed everything. So this is a cloud over some pollution, or over some sands that are found in the ocean. So we have some really big disturbances in the ocean. The classical or the traditional solution just labels everything as a cloud, while our solution nicely delineates the cloud, leaving the ocean as clear sky. Another example, I think is the same current here. You can see that everything is labeled by the standard product, while we nicely detect the cloud. So this was, let's say, an upside. 5 or 4 months after the project has ended, we went to some conference like this one, and we talked about what we did. One professor that is in Earth observation field for about 30 years told us that, okay, you rocked, actually. So that 90-something% was really good for Earth observation. Moreover, big guys like ESA, they don't bother with clouds. So this is a cloud mask, a stock cloud mask produced by ESA for Sentinel-2 satellite. Sentinel-2 was the second Sentinel-2, was launched, I think, last year in June. So it's a pretty fresh hardware, and they didn't bother to do a proper cloud mask. Okay, some takeaway words, okay? Machine learning is not a big hammer that can nail all the problems. You can really dump it on your foot, and it's really painful, especially if you're overfitting. Okay, this is the worst thing that can happen to you: overfitting. Okay, never forget this. When you're doing machine learning, you have to think, okay, this is my data. How am I overfitting? How am I splitting the data so I'm not overfitting? Okay, this is vital. This is the most important thing, because anybody can pick up a smarter algorithm, like decision tree or neural nets, whatever, you just import a different library, okay? But when you're delivering it to the client will call, well, you know, nobody likes my new recommender system. I mean, it would be better to just put random products on the recommender page. So this is overfitting. It works on my computer, but it doesn't work on the client's computer. Another thing that you should be prepared of, 90% in this project, 90% of the time was consumed doing data cleaning and domain knowledge. 10% we did machine learning. Okay, we had some problems with too much data. No, this is a quote. But the real problem is that you have to clean your data. Okay, and be prepared to spend a lot of time in this part. Just one idea, and then I'll be gone. Please raise the awareness around you, with your colleagues back in your companies. Start learning machine learning. There are very, very, very great courses, lectures online, starting with NDRNG and Fast AI and etc. Just start learning. And one other thing, important thing, try to bring this kind of projects in Cluj, okay? We have a great community here, big data and data science community. They had meetups like every 2 weeks or so. We had great people here, so please bring this know-how, please bring projects with machine learning here. At one point, this software bubble will burst. And everything that is web, mobile, or whatever, it will just disappear overnight, okay? My bet is, my personal bet is that machine learning will stay, okay? I don't know, I might be wrong, or I have no idea. Anyway, the most important thing is never give up. Thank you. We have time for 2 questions, maybe 3?
Yeah, we have time for more than 2 questions. Thank you
Okay.
for the great speech. And let's see those hands up. Who has a question for Christian? It's the last keynote.
Okay.
You're off the hook,
Thank
apparently.
you. Yes.
You're off the hook. Let's give him a round of applause.
Thank you.
This was, as I said, our last keynote. Next up is our last startup pitch, and then a few closing remarks. Therefore, I welcome again on stage Paul to introduce the last startup.
I know it's end of the conference, so if you guys would just like to stay for 3 more minutes. This startup came from a few hundred miles to pitch today, so let's give him just 3 minutes to talk about an awesome post-deployment feature management tool. Comment ça va? Good, best of luck.
Hello everyone, my name is Sava. I'm a founder of Canary Switch. We are building a post-deployment feature management system. We're from Chisinau, by the way. How many of you are developers here in this conference? Please raise your hand. So many of you. Cool. Then you most probably are scared of, does it work? Okay. Most probably you are afraid of, I don't know, bugs in production. Moreover, you most probably are afraid to do refactoring, to do, I don't know, release some new functionalities. And it's a well-known thing. The developers developed a lot of new tools to do that, even new job position like QAs, the guys who are checking that the code is working good, or TDD. There is another technique what I want to talk to you about. It's canary release. It's a technique in which you can actually release your new version of the software to a subset of your audience in order to see how it will comport on live, how the platform, how the system is performing on production. So we are developing Canary Switch platform, which actually enables you to release functionality to a subset of your audience, for example, to some beta users, 10% of your audience, and to get the feedback from your system. For example, how the system is performing, or maybe from the business part, how some KPIs are increasing or decreasing. So For this, we are providing actually an SDK which integrates easily within your code, within your software at the language level, and gives you possibility to with some if conditional to actually control the flow of your application, which functionality is enabled or not. And you'll have an interface in which you can enable or disable for a specific audience a set of functionalities of your platform. We have an awesome team of developers with more than 5 years of experience. So please join us at canaryswitch.io and leave your email. We'll send you more information about our product. Thank you.
Okay. Thank you. We just bear with us 5 more minutes. We're going to announce the winners for today's contest. We're going to have GNX, Quick Mobile, Auto World, and Cherry coming here to give out the prizes to the winners today. So we're waiting for them. Come here, guys. Let's give him a round of applause. So first up, we have GNX. We have a drone and a smartwatch. So let's see who's the lucky winner. Me? Okay. The first one goes to a smartwatch. So this is for the smartwatch. Here you go. Carmen, what? So the winner is Carmen. We have her phone number. We'll be calling her to give her the details about the price and how she can pick it up. Okay, so this is for the smartwatch. Let's pick somebody for the drone.
Thank you. Moldovan Andrei. I don't know if he is here.
Is there anybody called Moldovan Andrei here? Come on up.
So you're the happy winner.
Wow, congrats.
There you go.
There you go, enjoy it, and thank you for attending Happy Devs, Dev Talks, sorry. Coming up next, Auto World. Come on up. Here you go. So.
Yeah, hi guys. My name is Roger. I'm from Auto World. I represent the Ducati brand, the Audi brand, and the Volkswagen brand here in Cluj-Napoca. We have a special prize for you. It's not necessarily about an Audi to test drive a whole weekend. It can also be a Volkswagen. Maybe, let's see. I will need some help.
Okay,
if
I will gladly help you.
Yeah, okay.
So just to be clear, the price is a?
It's a full weekend with an Audi, brand new car, the latest model, I think. If you can choose from our
nice
test drive auto park, or it can be a Volkswagen, a whole weekend. We will get in touch with the winner, and we'll see when he or she will be available, or when our cars will be available. So it will be a negotiation, I think.
Okay, so let's pick somebody.
Okay, close your eyes, please. There are a lot of potential winners. You can, yeah, please.
I'm gonna mix it up a little bit.
Like you mean it, please.
Like I mean it.
Okay.
Okay.
Yeah, right now we are live, I think, on our Facebook web page, Auto World Audi. Just 1 second.
There you go.
We like to be as transparent as we can. Please, come. Let's broadcast it also on Facebook. And the winner is Alin Preduț. Let's see if everyone can see. Preduț Alin, if he's around, I will give him a round of applause, but if he's not, I will get in contact with him on email, or I will try to call him.
So congrats to Alin. He's going to be contacted by our colleagues at Outer World. And then, thank you very much.
Thank you, thank you.
Up next is Cherry. So we are choosing the winner for this amazing chair. Wow, I kind of like it. Not looking, not looking. Just mixing. There you go.
And the winner is Opera Roxana Adochina.
Is Roxana here? Opera Roxana, are you with us? No. Okay. Congrats for winning this amazing chair. The good people at Chair will contact you and give you all the details about getting your prize. Thank you very much.
Thank you.
You can take this with you, I think. Thank you. Give them a round of applause. So thank you very much for offering these prizes. And this being said, I will ask you to bear with me 2 more minutes for the final thoughts. First of all, we would like to thank you all for attending the 3rd edition of Dev Talks Cluj. It was a busy, busy day with 10 keynotes, 10 startup pitches, and 2 panels. We hope that you enjoyed attending this event, but most of all and most importantly, we hope that you learned something today. This being said, after all the dev talk, it's time to party. So we're waiting all of you to attend the party at Berăria Ursus Euphoria Music Hall, starting now, so everybody should head out there. And I would also like to ask you kindly to, where's the link? Yeah, to access this link, and if you would like to give us some feedback regarding the event, what do you think you could do better next time, so we can make sure that Dev Talks 2018 will rock even more than this year. Thank you very much for attending, and see you at Berăria Ursus. Thank you.